I hope my screen is visible and I'm audible to you all. So
Yes,
today
ma'am.
we'll be
Yes,
revising week
ma'am.
Yes,
three
ma'am.
and four. Okay. We'll revise week 3 and 4 today. And so week 3 is about quadratic equations. So your quadratic function, what is the function? Should we wait for more people to join or we can start, right? Okay, it's already 8:10.
Yes, ma'am, we should
So,
start.
uh, okay. So this is today we have the slides for week 3 and week 4, so we can quickly revise things from here. This is the equation of your quadratic function. So your quadratic function is supposed to look like this, where a should not be 0, otherwise it will become linear, right? Otherwise this thing will disappear and the entire thing will become a linear function instead. And then the graph of these kind of functions always looks like this, where it's either this or this. And in particular, if you have to discuss, that's called a parabola, and the axis of symmetry is this. So if you have this parabola, then this, where if you will fold it along this line, this side and this side will overlap. This is called the axis of symmetry. And where your axis of symmetry meets your graph, this curve. So let's call this fx. If this is fx, and this is axis of symmetry, so where these two intersect is called your vertex, which is minus b by 2a, comma, f at minus b by 2a. So this is that vertex point. And if a, this is the case when a is greater than 0. That means that if your leading coefficient is greater than 0, then that's how your parabola looks like. For a less than 0, it opens downwards. So it looks like this. And if let's say, then we have this, that, and that, I think there's one thing not mentioned here, maybe it will be mentioned later, that if you have a graph, a parabola, and if it's like this, then these 2 points, let's say this is your axis of symmetry, then these two are your roots, right? Roots of the parabola.
Yes.
And these two are at equal distance from this axis of symmetry. So if this is your axis of symmetry, then this distance is the same as this distance. So these two are at equal distances. So let's say if you already know this point, let's say this is 3 comma minus 6, let's say, then this point will be 3 comma 0. And because this point is 3 comma 0, so this point is going to be 3 plus a comma 0, and this point is going to be 3 minus a comma 0, right? So that's how it works. And then coming to slopes and tangents. So the slope of tangent is basically this. Tangent is
Ma'am,
if
can
you
you
have a,
please repeat the last line?
which one? This one.
Ma'am, parabola's last line. After roots.
After roots, are you talking last we discussed this thing, right? That they are at an equal
Yes, sir.
distance from the axis of symmetry. Okay. So this is if your vertex is 3 comma minus 6, let's assume this is the vertex, right? If this is 3 comma minus 6, then this point where your axis of symmetry meets your x-axis should be 3 comma 0, right? And then we're
Yes,
saying
ma'am.
that from this point, both of the roots are at equal distance. So let's say if this distance is a, then this distance is a as well. So if you're moving to the right, this point should be 3 plus a comma 0. And if you're moving to the left, this point should be 3 minus a comma 0, right? That's it.
Okay, thank you, ma'am.
Okay. So coming to this one, your tangents are basically to any curve, but in particular, we're discussing quadratic functions. So tangent at this point will be a straight line that just touches this curve at this point and then passes. So this line and this curve touch only at one point. That's called your tangent, and it's for your quadratic equation. It's given by 2ax. So if your quadratic function is ax square plus bx plus c, then the tangent to it, not the tangent, that this is not the equation of the tangent, but the slope to it is given by 2ax plus b. And slope is basically the angle of the tan of the angle, tan of theta. Let's say this angle is theta, and this is the tangent. So your slope at this point, let's call this point xy. So if this is your point xy, then the slope at this point is simply the tan of theta, where theta is the angle made by the tangent at this point to this curve with the positive direction of x-axis. So this is the idea. This is your slope, right? This is your slope. And for a parabola, your slope is, because you cannot be using tan theta. So what we use for it is your slope is given by 2ax plus b. So for a parabola which looks like this, for a quadratic function which looks like this graph is a parabola, ax square plus bx plus c, the slope is going to be equal to 2ax plus b. Now, if you have to find that x is equals to 2, or in particular, if you have to find the slope of this at, let's say, 2 comma 4 point, right? Then this should be, you put 2 here and you will get the slope. That's it. So that's for the slope. And
Excuse me, madam.
this, yeah,
So, madam, if the slope is 4,
okay.
then what would be the angle? What would be the theta?
If your slope is, you're saying your slope is 4 and slope is tan theta, right? So this will be 4, and then you can just use tan inverse. That you cannot solve this. There's no, you're not supposed to know these values, and you wouldn't be give, this is, if you're asked something like that, you just have to use your calculator. That's it.
So, ma'am,
Yeah.
Okay.
ma'am, may you please explain me tangent again?
That was for you to know slope. That's not important here, but I'll explain that again. What your tangent is, let's say you have a curve. Let's say this is your graph, right? This is your this is your quadratic equation, quadratic functions graph. Then a tangent, let's say you're asked to graphically, what does it mean when we say that we have to find the tangent at point A comma B on this graph? It means if this is the point A comma B, then the line that passes through this point and it touches this curve only at this point. So if this is your point A comma B, then there should be a straight line that passes through this point and it touches this curve only at one point. That's called your tangent, right?
So, ma'am,
And
where
the
the
slope, yeah,
ma'am, where the point is touching is the tangent. The line is
this,
touching the parabola. That is a tangent.
yeah,
Right?
this line is called the tangent line. Tangent,
Okay, ma'am.
let's say this function is fx, okay,
Okay.
and this point is A comma B. Then I say that this straight line that I've drawn here, which only touches fx at A comma B, is called tangent of f at A comma B. That's it.
Hmm.
This straight line is called tangent. And
Ma'am, means
this angle,
point A comma B is tangent.
no, the point is not tangent. This line is tangent.
Okay, okay.
And this, let's say if this makes angle, this is a line, right? A straight line, and this is your x-axis. So this straight line, the angle that it makes with this axis, this angle, let's say it's theta, then tan of this theta is your slope. That's what slope actually means. But for you to find slope, if you've been asked to find slope, you can't find this angle, right? There's no way you can find this angle. And most likely you wouldn't be given angles there. So you're not supposed to use this tan theta formula there. There is a direct formula for the slope of quadratic function at a point x, which is this. So if this is your
Okay, ma'am.
function, if your function looks like this, then the slope of this function, instead of doing tan theta, what you can directly do is you can use this formula for slope. This gives the slope. So let's say your function is 2x square plus 5, and you have to find the slope of this function at, let's say, 2 comma 5, 2, and if I'll use 2 here, this will be 4, 8, and 8 and 5 is 13, right? So let's say 2 comma 13 lies on this curve. Now you have to find the slope of this curve at 2 comma 13. Then how do you do it? This is, compare it to this form, ax square plus bx plus c. So the slope is given by 2ax plus b, right? Then your a is 2. So put 2, a equals to 2 here. B is 0, right? So put b equals to 0 here. So you will get 4x. So, and you have to find the slope at 2 comma 13. So put x equals to, this is x, this is y. You have to find the slope at this point. So put x equals to 2 here. So your slope at, this is slope of 2x square plus 5 at the point 2 comma 13, which is 8. Is that okay?
Ma'am,
This is
first
it.
you
This
have
is what
find
you
the
have to
slope.
do.
Ma'am, 2x plus b means first you have find 2x plus b, then you are finding slope.
This 2ax plus b is the general slope for any point x comma y. This is
Okay.
this is general form of slope. Slope at any point x comma y is given by 2ax plus b. If your equation is ax squared plus, if your function is ax squared plus bx plus c, then the slope for this function at the point x comma y is given by 2ax plus b. But I have to find the slope at 2 comma 13, right? So I
Yes.
should put x equals to 2. That's why I've put 2. Is that okay?
Yes, ma'am.
Okay. Then moving to the, now if you have to find the equation of this tangent, this tangent is a line, right? So you should be able to, what all do you need to find the equation of a line? How can I find the equation of a line? We've done this, right? In week 2. So either I need the slope and 1 point, or I need 2 points, right? To find the equation of a line. Now I have been given, if you have to find the equation of this tangent line, then what do you need? You already have the point at which this is a tangent. So your point is given x naught comma fx naught. This is given, and the slope is slope at this point. We just checked what's the slope at this point. By the way, the slope of this, okay, just 1 second. One thing that I didn't mention is that this is a line and this is a parabola, right? And the slope of this parabola at this point and the slope of this line at this point is the same. Is that okay? So that means the slope of this line at this point is 2ax plus b, and the slope of this point, this parabola at this point is also 2ax plus b. So if you have to find the equation of this line, this is the tangent line.
Excuse me, ma'am.
Yes.
The slope of the parabola at that point is not definitely that slope that we have got for the tangent, right? Because at every point we can draw infinite number of tangents, and infinite number of tangents would have different theta values, so the slope will also differ.
So you if this is a curve at this point, you cannot draw infinite number of tangents. You can, there's a unique tangent which touches, what does tangent means? It means this is a line that passes through this curve and it touches this curve only at one point. So that there should be a straight line that touches this curve only at this point. That's it. That's your tangent, right? So there's a unique line. Tangent is always unique. This line is unique. There are not infinitely many tangents to a curve at a point.
Ma'am,
Yeah.
ma'am, if we do derivative, then by after doing derivative, then putting the value of x in the equation, we can also get the equation, right?
That, yes, that's what we've done. 2ax plus b is the derivative of
Oh,
this.
okay.
But a lot of people don't know derivatives yet, right? That's why I'm not using that term here.
Okay. It's okay.
Okay. So tangent at point. So if you have to find the equation of this line, this tangent is a line and you have to find the equation of that line, then that, what's the formula? You have been given that your tangent line passes through passes through the point this. Let's call this point x naught and fx naught, right? It passes through this point, and the slope at this point is 2ax plus b is the general form. And at this particular point, your slope becomes 2ax naught plus b, right? That's what we discussed here. So slope is this. So that means you have been given a line, and one point is given and slope is given. So that how do you find the equation of that line? It's y minus the point given, y coordinate of the point given. So y coordinate of the point given is fx naught. Then x minus x coordinate of the point given, which is x naught. And then the slope here, right? 2ax naught plus b. Is this okay? So that's
Please
how you
come
find the
Yes,
equation of
ma'am.
tangent.
Madam, please
This
come
is
again. This how you multiply these two things and get the slope?
which two
Right
things?
over right.
This is the slope. We have not multiplied anything to find the slope.
No, this is the x minus x naught.
Okay,
Remember
let's
that.
say if, one second,
Remember
if
both
m is the
float
slope,
rules, like.
if m is the slope of a line, and that line passes through the point x naught, y naught. So this is a point on the line, and this is the slope of the line. Then how do you find the equation of that line? It's, what is it? Y minus y naught equals m times x minus x naught, right? So if the point is given to be x naught comma fx naught, and the slope is given to be 2ax naught plus b, then this should be the equation, right, of the tangent line. Is that okay?
Okay. Okay.
Okay.
Okay, that means the on the tangent there was one given point. This is the given point.
Yeah. The point where it meets this parabola is the given point. This is the given point.
And that you termed as x naught and fx naught.
Right. This one.
Okay.
Is this okay? Okay. And this is what I've already
Excuse me,
mentioned this,
ma'am.
that, yes.
If point is not given, can we calculate using minus b by 2a and then put it in the equation?
If it's
If
not
equation-
given, if the point's not given, is that what you're saying?
Yes, ma'am.
If the point's not given, then why would they ask you to find the tangent? Where would you find the tangent? You need the point to find the. See, at this point, you have a different tangent. At this point, you have a different tangent. At this one, you have a different tangent. If the point is not given, then how would you find the tangent?
Okay, ma'am.
Okay. Okay, then moving on. This is about quadratic equation. So we've already discussed the general form. Then roots are the x-intercepts. Yeah.
Can you explain that equation that's a y minus f of x naught something written beneath the tangent introduction line above?
This one. This one,
Ah,
right?
yes, ma'am.
See, this is your parabola. And let's say you have to find the equation of the tangent line at the point. Let's call this point. Instead of calling it xy, if it lies on this curve, this is a point that lies on this tangent line, and it lies on the parabola as well, right? So if the x coordinate of this point is x naught, then what should be the y coordinate? If this is
F of
fx, it should be f of x naught, right? So this is the point x naught comma fx naught, which lies on the line, tangent line, and it lies on the parabola as well. And you have to find the equation of this tangent line. So now you have one point that lies on the tangent line, and you have the slope of the tangent line, right? This is the slope. This is the slope of this parabola in general. But at this point, the slope becomes 2ax naught plus b, right? At this point.
Yes, ma'am.
And at this point, the slope of the parabola and the slope of this tangent line are same. So the slope of this tangent line is 2ax naught plus b at this point. And in fact, in general, the slope of a tangent line is constant, right? If you have a
I
straight
see.
line, then the slope of it is constant. So this 2a x naught plus b is the constant slope of this tangent line. And this is one point that lies on this tangent line. Now you have a point that lies on that line and you have the slope of that line. So you have to use the slope intercept form and find this. That's it.
Ma'am, could you give an example on numerical?
Okay, let's say you have been given the parabola is, let's take this parabola only. Let's say your parabola is given to be this. This is your fx, let's say 2x square plus 5. And you have to find equation of tangent at 2, 13. Then first thing that you do is, if this is 2, 13, first thing you need to find the slope of this parabola at 2, 13. So what is slope of
4x plus
fx?
5.
4x
4x
plus
plus 5.
5. How are you left with 5? This is 2x square plus 5. Slope of fx is 4x
Okay,
square.
yeah, yeah.
4x.
Yeah.
And
4x.
at 2, 13, your slope will be equal to, okay, this is 4x,
Ma'am,
right?
4x
So this
only.
will be 8, right? So this is 4x and this will be 8. So your slope is 8 and you need a point. You already have a point, right? So your point is 2, 13. Slope is 8. So equation of tangent line should be y minus 13, this is equals to x minus 2, this, and then the slope, which is 8.
Y equal to 8x plus 11.
You can solve this, right?
Yeah, ma'am.
Just solve this and you will get the exact equation.
हेलो मैम
Yeah.
मैम मैं आप जहाँ पे फाइंड किए हैं x इक्वल टू 8 कैसे किए हैं वापस से दिखाइए
This one,
यस 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 इक्वेशन ऑफ टेंजेंट एट 2, 13 सो स्लोप ऑफ x आपने 4x कैसे रखा
your equation is, okay, your parabola or your quadratic equation was 2x square. We have taken this. We have taken fx to be 2x square plus 5, right? Now, if you will find, I don't know what method you are using. A lot of people don't know derivatives. So let's go the usual way. If this is your parabola, then the slope is given by 2ax plus b, right? If this is function, slope is this, right?
2x plus b
Slope of function 2ax plus b, right? What is a here? It's 2, right? So 4x. What is b here? It's 0. So it's this.
ओके मैम
Okay. So then we have this thing where to find there are methods to solve this equation. Your zeros are okay. So there are three methods basically to solve your quadratic equation. One is using factorization. The simplest one, easiest approach is quadratic formula. Use the quadratic formula, it always works. And this is your quadratic formula. So if your equation is this, if your function is fx is equals to ax square plus bx plus c, then this will be the zeros of your zeros are given by this. Zeros of this function ax square plus bx plus c quadratic function is given by minus b, where b is the coefficient of x. So this is the formula, right? And then for factorization, what you can do is just 1 second. Yeah. So for factorization one, what you have to do is, let's do one example on this. Basically, you have to split b into two parts such that the product of it, the sum of it is equal to b. So you have to split it into two parts. Let's call it b1, b2, such that b1 plus b2 is equals to b, and the product of b1, b2 should be equal to ac, the product of a and c, right? Let's do it using an example. So let's take the simple example, x square plus 5x plus 6. Now this is 1 here, right? Or you can take 2 here. 2x square and take 3 here instead. So now you'll have, if you have to split this into two parts, so how do you have to split it? Into b1x plus b2x, such that b1 plus b2 should be equal to 5 and b1 into b2 should be equal to 2 times 3, the product of these two. Right? So what should it be? So I can split it into 2 and 3, right? If I'll split 5 into 2 and 3, then 2x plus 3x is equals to 5x. And the product of 2 and 3 is this, 6, right? The product of 2 and 3, and this is same. So how you can split this thing? You can write this as 2x square. 5x you can write as 2x plus 3x. And here you can take 3. So this will be, you can take 2x common from here. You will be left with x plus 1. And you can take 3 common from here. You will be left with x plus 1. And this is, take x plus 1 common from both terms. You will have x plus 1 here and 2x plus 3 here. So now, if you equate this thing to 0, you will get x is equals to minus 1 and x is equals to minus 3 by 2. Right? That's how you use the factorization method. Then completing the squares is the same as, you don't need to complete the squares, right? And completing the squares, by the way, leads to the quadratic formula. So what you'll eventually be using, even if you're using the completing the squares method, you will still be using the quadratic formula only. So you can just directly use this formula to find the roots. And then this is about the discriminant. This thing in the square root is called the discriminant. And a lot of things depend on the discriminant. So let's say if your discriminant is positive, then we say we have two distinct real roots. Two distinct real roots mean your parabola would be this. One real root here, one real root here. So this is what it looks like. Or if it's a downward parabola, it can look like this. Right? Let's remove the y-axis.
Roots can be also find using the parabola.
What can be found?
Ma'am, we can find the roots also by the parabola. Na?
Parabola as in?
हाँ मतलब मैम जैसे कि पैराबोला जिस लाइन पे टच कर रहा है, जैसे आपने दो पैराबोला बनाया है इस लाइन पे, वो दो पॉइंट पे टच कर रहा है, तो ये दोनों पॉइंट भी तो रूट हो गए ना मैम, जो एक्स एक्सिस पे जो टच कर रहा है.
वो तो रूट होंगे, लेकिन आपको पता थोड़ी ना होगा वो कौन से दो पॉइंट्स हैं.
Okay,
If it's mentioned, then well and good. If the points are mentioned to you, then obviously you will know that these two are roots. This, the x-axis, the x coordinate of this and x coordinate of this are the roots of your quadratic function. But if it's not given, if the points are not mentioned, then you will have to find them, right?
Okay, ma'am.
Okay. So these, if your roots are distinct, then your parabola looks like this. Or if it's or this one. If your roots are, if your discriminant is 0, that means if this entire thing turns out to be 0, then that means you have either this case. I should draw this here. This is this. This is x-axis, and your parabola would be this. Yeah.
Ma'am, we can use completing the square method only when b is a even number. Can we use it as odd also?
This b?
Yes.
It doesn't have to do with b being even and odd. Completing the squares has nothing to do with it. Basically, when you do completing the squares, if you have seen the derivation of completing the squares thing, you must have seen that at the end you get the quadratic formula, right? When you do the entire thing and then you solve for x after completing the square, let's say you got x minus 5 square equals to something, right? But I don't want to do that entire derivation here.
Okay.
But you do get it, right? By completing the square leads to this formula. This is the process. It's like, you can look at this like completing the squares is the process, and this is the result that you get. So for the solutions, you only need quadratic formula. We don't need completing the squares, the entire method. But you should know how completing the squares is performed. Okay.
Completing the square can be done regardless of whether b is even or odd, but
Yeah.
just that it is odd, it will be little more harder, right? Because we have to divide by 2 and then square it. So if it's odd, it will be like messy numbers.
If B is odd, then how do you know? Let's say B is 10. Let's say it's 15. This is odd. Let's say your A is 5. This is 5x squared plus 15x plus 15, let's say. Now, if you'll divide this thing, that's what you're talking about, right? You will get 3x
Divide
plus
by 2, B by 2, right? And then
3.
we have to square it.
Yeah,
For
that's okay. You're talking about the 3 by 2 adding and then, okay. Yeah, it's going to be lengthy, but it's still possible. It's not that lengthy, by the way, but okay. Okay, then
Ma'am, one question that
yeah,
in the exam it will be written that the answer should be solved by completing square method or quadratic formula or whatever.
it's a computer-based exam. It's not a written exam. You don't have to write anything here.
No, I
They
thought
don't
that
care
the
what
answer
method you
will.
use.
Okay, okay.
They just care about the answer. You will have to type the answer there, or you will have to tick the answer. That means they don't care what you're using, just get the answer right. Is that okay? Okay. That's why this is factorization anyway does not work all the time. You cannot rely on factorization method. The only method you can rely heavily on is, or entirely on, is this quadratic formula one. Just learn this and you will be able to get through all the questions, all the solutions at least. You will be able to find all solutions of all kind of quadratic equations. Is that okay? This formula is enough.
Excuse me, ma'am.
Yeah.
Ma'am, I think that we have that given the discriminant for greater than 0, 2 distinct real roots, and for equals to 0, 1 real root. I think that it maybe also depends on A greater than 0 or less than 0. So can you please give the all the graphs for A
Okay.
greater than 0 or A less
Okay.
than 0?
Let's come to this one. For A greater than 0 means yeah, this is good. That's why I've drawn 2, right? Because we don't know what A is. This is for A greater than 0. This is for A less than 0. Is that okay now?
Yes.
We don't know what A is. We in general know that D is greater than 0. That means either my curve looks like this or it looks like this. Right? If I
Yes,
don't
ma'am.
know anything about A. Then coming to this one, if I have repeated roots, then my curve should look like this. It touches the x-axis and then moves back there on the positive side, or it touches the x-axis and moves back on the negative side. Right? Now this is again the same. A greater than 0, A less than 0. And for the complex conjugate roots, let's say you have complex roots. That means it does not touch your x-axis at all. That means it's either this, if A is greater than 0, or it's this, when A is less than 0. Is that okay?
Yes, ma'am.
So these are your curves. And then we have, so if you have to find the, for quadratic functions, if you have to find the global maxima or minima, all you have to do is,
Ma'am,
yeah,
ma'am, for which curve discriminant greater than 0 and discriminant less than 0, can you please say?
for these ones, when your graph touches the x-axis at 2 points, for this one, your discriminant is greater than 0. Because your formula is minus b plus minus square root of d by 2a, right? So if your d is not equals to 0, then you're going to get different values, minus b by 2a plus root d. One time you'll get this, and then the other time you'll get minus b by 2a minus root d by 2a, right? So if your d is not equals to 0, these two values, these are the two roots, right? They are going to be different if d is not 0. And they are going to be same if d is greater than 0 or less than 0. Sorry, they are going to be different if they are not. If d is not 0, they are going to be different. If d is 0, then they are going to be same. If you put d 0 here, you will get both the roots as minus b by 2a minus b by 2a, right? So
Yes,
that's
sir.
the case when your roots are repeated. And when your roots are repeated, your graph looks like this. It touches the x-axis at only one point. And this root is repeated. This is the root. It's repeated 2 times. Is that okay?
Yes, ma'am.
And when you have this, if your d is less than 0, that means I'm not sure if you guys have done complex numbers and all, but then your roots will be complex. Complex as in non-real roots. You will get non-real roots. And because your roots are not real and x-axis is real axis, you cannot plot your roots here. That means your roots, this parabola is not going to touch your x-axis because it has no real roots. So it's either like this or it's here. Down the x-axis
Yes,
or
ma'am, I
up the
understand.
x-axis. That's it. Okay. Then we have this. So for you to find the, let's say this is your parabola, then you're going to have a minimum here, right? And this will be your minimum
Yes.
value. This height is the minimum value, right? And what's this height? This point is minus b by 2a, comma f of minus b by 2a. So the height is f of minus b by 2a, right? So the minimum
Yes.
value for this curve will be f of minus b by 2a. And it's attained as in this value is obtained at the point f of, minus b by 2a. So it's attained at minus b by 2a and the value is f of minus b by 2a. Is that okay? So if you have to find the maxima or minima for a quadratic function ax squared plus bx plus c, all you have to do is you have to find the slope. So this is 2ax plus b. One thing you can do is, if you don't want to get into the slope thing, you only have to find minus b, f of minus b. So that means this is your function, right? In place of x, you only have to put minus b by 2a, minus b by 2a square plus b minus b by 2a plus c. That's it. This is going to give you the minimum or maximum, depending on whether your parabola is upward. If it's an upward parabola, then you will get a minimum. If it's a downward parabola, this thing will give you a maximum. Is that okay?
Yes, application of derivative.
Right. So axis of
Did we
symmetry. Yeah.
did we discuss the square method?
Which one? Completing the squares.
Yeah. Oh, b by
No,
2 square.
we didn't discuss it. Do you want me to discuss that method here?
Okay, no problem.
So,
That's
ma'am,
No,
we will
no
use
need.
discriminant method, this quadratic formula.
Okay, but there could be MSQs and MCQs based on everything, right? So just go through it. You might not need factorization and this method for other things, but you can need it for MSQs. MSQs can be asked on these things, right? What is possible, what's not possible. So just go through everything once. Okay. Then vertex, this is done, right? Axis symmetry always passes through the vertex. We've already discussed. In fact, vertex is the point where your axis of symmetry touches your curve. So if this is your parabola and this is axis of symmetry, then vertex is where your axis of symmetry and this parabola intersect each other. This is the vertex, right? We've already discussed this. Then roots are symmetric about the axis of symmetry. We've also spoken about this thing that if this is, we discussed this here, right? That's symmetric about this axis of symmetry. That means if one root is at a distance, let's say d, if this distance is d between this root and this point on the axis of symmetry, if the distance is d, then this distance is also d. That's what it means. And then next up we have, if alpha and beta are roots, then the sum of these two roots is, equation is always ax squared plus bx by bx plus c is equals to 0. So this, or fx. So if this is your function given, then the sum of these alpha beta roots and the sum of these two roots is minus b by 2a. This is b, this is a, and alpha beta, the product is given by c by a. And the signs of the discriminant determines the number and type of roots. We've already discussed it here, right? This one. This is what it means. Sign of this is going to decide whether it's a repeated root or it's two distinct roots or non-real roots, what's going on. So that is what discriminant tells us. Then next up we have, yeah.
And what does 0.4 means? This one, if roots are alpha and beta, Yes.
of this. If roots of ax square plus bx plus c, if this is your quadratic function and the roots of this are alpha and beta, then the sum of roots alpha plus beta is minus b by 2 minus b by a, where b is the coefficient of x, a is the coefficient of x square, and the product of the two roots that you've gotten, let's say this one, x square plus 5x plus 6 we did, right? So the solutions of this were, I think, what are the solutions? Minus 2 and minus 3, right? So
Yeah.
this means now if these two are your roots, let's call
Yes,
this
ma'am.
alpha, call this beta. Then the sum of these two roots, it's minus 2 and minus 3. So it's minus 5, right? This should be equals to minus b by a. B is this, a is 1. So this is minus 5 by 1, which is correct, right? And then it says that the product of the two roots, minus 2 minus 3, which is 6, should be equal to
It
c
means,
by
ma'am,
a.
without calculation, we can find the roots. Means addition and multiplication of roots.
Yeah, you can find the sum of the roots and product of the roots.
Okay, ma'am.
But for finding the exact alpha beta, this is, if you will use these two equations to find alpha and beta, right? You're going to be directed to the same equation. So you'll have to use the quadratic formula eventually. You can't find the roots from here.
Okay.
Okay. Then can we move to week 4? Is anything
Yeah,
left
ma'am.
from week 3?
Yes, ma'am.
Week 3 is done, right?
Yes, ma'am.
Nothing important left, I think.
Yes, ma'am.
Okay, then week 4 is this about polynomials. This is a general form of
Ma'am,
your
I have a
polynomial. Yeah.
hello. I have a
Yes.
doubt in week 4, week 3. Sorry.
Yeah.
Can you discuss it later or no?
Let's discuss that doubt later. Let's go through all the
Okay.
questions and week 4 summary, and then we'll come to your doubt. So a
No,
polynomial function.
in extra practice assignment.
Okay, we'll discuss that later. So if this is your polynomial function given, then an should not be equal. This is a polynomial of degree n. You can say it's a polynomial of degree n. And for this to be a polynomial of degree n, you need to make sure that your n is not equals to 0. Okay, then the range of range depends on the degree and coefficient. That's obvious, right? If you have 2x square plus 5, and then if you have 2x plus 5, it depends on degree, coefficient, and one thing that's left is, because if you have seen the graphs, you must have noticed that sometimes your polynomial looks like this. On both ends, it's tending to plus infinity. That means on the negative side, it cannot take all values. That means it has a fixed range from this point to plus infinity, right? So it's like this. If this is your polynomial, if this is the graph of your polynomial, then its range is going to be something like this, right? From a to infinity, where a is a negative number, right? And if this is your curve, then it's going to be from minus infinity to b, where b is this height, right? Okay. Then these are some basic things about polynomials. If your degree is 0, this is the highest, this highest degree, highest n is called the degree here. And this, for this, an should be non-zero, right? So constant is like this, like 2, 3. If your function is 2, I'm just writing one example, fx equals to 2. Now this is a constant polynomial, or let me call it px is equals to 2. For linear, you can take px is equals to 2x plus 1, so 1 degree only. And then for quadratic, you can take x square plus x. For cubic, you can take x cube plus 1. And for quartic, you can take x to the power 4 plus 9x square. So these are your degree and what are they called, 0-degree polynomial and it's called and what it's called, and then you have basic addition and
Madam,
subtract. Yeah,
that curve what you have shown in the previous slide, well,
this
this
one
curve, so madam, it is this measured from left to right, correct?
from left to right.
Left to
What?
right now. So
Yeah.
from if you from left to right, what is this a you means? Means here the x coordinate is minus, y coordinate is plus. So you are mentioning all the y coordinate or what you mean? What is a?
We're talking about range. This line says that range depends on the degree and coefficient, right? And because your degree and coefficient influence whether your graph is going to look like this or your polynomial is going to look like this, right? It's possible that your polynomial looks like this. That means it extends from minus infinity to plus infinity, right? Okay.
So this would be minus a, na? That's what I.
I
Minus.
already mentioned that this is a negative number. I
Acha,
mentioned
this
it,
is a
right?
negative number. Acha,
Yeah.
Acha, okay. That is fine. That is fine.
Okay. If this is A, this line is y is equals to A, then this is your range, right? That's it. And then let's move on to this one. Addition and subtraction. We're not going to show how addition and subtraction works. So if anyone has a doubt in these things, how addition, subtraction, and multiplication works, then we can discuss it here. Otherwise, I think everyone knows this, right?
Yes, ma'am.
Yes, ma'am.
Okay. Then polynomial division is one thing here, where do we need to discuss polynomial division?
No,
It
ma'am.
works the same way as usual division. That's again a very simple topic. And your division algorithm is px is equals to dx, where this is your divisor, this is the dividend, and this is quotient, and this is the remainder. And one important thing to note here is that the degree of remainder has to be strictly less than, not equals to. So these two degrees cannot be equal. Degree of remainder is strictly less than the degree of your divisor. And that's when you stop. So this is a hint when you're dividing things and when you get the at here, if you get the degree less than what's here, let's say your degree is 4 here, and now you've got an x cube here, this means that you should stop here. This is how you know that we've gotten our remainder and we should not go any further, right? And then one thing that's not mentioned here is this is a bit oversimplified, or either your degree of R is less than degree of D or your remainder is 0. What is the degree of 0? 0 polynomial?
Not defined, ma'am.
Not defined.
Infinity.
So
Undefined.
this thing is not going to work when your remainder is 0, right? That's why these two things need to be mentioned together, that either your degree of remainder should be less than degree of divisor or your remainder is 0. These two things, either of these is going to happen when you're dividing one polynomial by other polynomial. Then coming to this one, zeros or roots. So your factor theorem is basically if x minus a is a factor of fx, then this means this happens if and only if f of a is 0. That means if x minus a is a factor of this, that means if x minus a divides fx, then f a should be 0. Like for example, let's take x square plus 2x plus 1. Now I know that x minus 1 is a factor of this, right? This is a polynomial. I know x plus 1 is a factor of x minus 1, x plus 1 is a factor of this. That means x is equals to, what's your a here? If I'll compare x plus 1 to x minus a, then what's my a in this one? A is minus 1, right? And if I'll substitute f minus 1 in this polynomial, then p of minus 1 is, put minus 1 here and you'll get 0. This is what your factor theorem means. Now, and your there's another theorem which is called remainder theorem, which says that if x minus a does, if you'll do this x minus a and dividing px, where px is a polynomial, like you're dividing px by x minus a, then the remainder is going to be equal to P of A. Is that okay? So this is your remainder theorem.
Ma'am, once again.
Yeah. Do we have a doubt here?
Ma'am, can you please
Can you give an
explain?
example?
Yes, of this
I have a
theorem.
doubt in the degree of the polynomial and degree of the remainder.
Degree of the polynomial and degree of remainder. What's the doubt?
I get confused like which like degree of the polynomial is equal to degree of the remainder minus 1. Those things confuses me.
Okay, let's say your degree, this is what, if you have a d here, you're dividing px by some dx, then degree of, if you'll compare degree of, we already know that degree of remainder is supposed to be strictly less than degree of dx, right? Then that means your degree of r, what's the maximum value it can take then?
Up to the degree of the divisor.
This one, right? Degree of
Divisor
dx
minus 1.
minus 1. Because it has to be, degrees are always
Yes,
natural
yes.
numbers. So that's why you do minus 1 here.
Okay.
Is that okay? So if
Ma'am,
this
Yeah,
is
yeah.
fine,
dividing it by a constant, would the degree change? It won't, right?
no.
So then degree can be equal.
No, it can't be equal. What's been done here is, if your degree, you're saying if you're dividing by a constant, then your divisor is a constant, right? And what's the degree of your constant?
0.
0, right? That means your degree. Now, if you're dividing by a constant, then what's your remainder?
Another
When
polynomial
you
of the same degree.
the same degree. 1 second. If you're dividing, let's say I'm dividing 2x square plus 2 by 2, then what's my remainder? It's 0, right?
Yes.
No, I think it will
You'll
be
get
x
0.
square plus, x square plus 1, right?
Your remainder is, that's why I said you stop the division algorithm when you get degree of, either you get remainder equals to 0. How do you know when to stop this division algorithm? Either you get remainder equals to 0, or you get the degree of remainder less than this, less than the degree of this. Now the degree of this is already 0, and you can't get any degree less than 0. That means your remainder's degree is not defined, so it has to be 0 only. Do you get it?
Ma'am, won't we get like x square plus 1 when we divide it by 2?
You will do this, right? X square plus 1. Then you will do 2x square plus 2. So you're going to get 0 here, right?
Yeah, got it.
But you don't have to check
Choose
this
between
entire thing.
quotient and remainder. Okay, sorry.
Okay. So that's why we say this thing is missing here. Either your remainder is 0, or, so if you're getting remainder equals to 0, now this does not hold, right? This is not going to hold if your remainder is 0. This is not valid for remainder equals to 0. That's why we write either the degree of remainder is strictly less than degree of divisor, or your remainder is 0. One of these two things is going to happen in division algorithm. Is that fine?
Yes, ma'am.
Okay. Now, this.
Ma'am, can
Yeah.
you explain what's part of this? Yeah,
Explain what?
remainder
This
theorem.
one?
Remainder theorem.
Okay. Let's do, we've already seen an example of factor theorem. Let's do remainder theorem. Let's say you have x square plus 2x plus 2 this time. And now I'm dividing by, again, I'm using the same thing. I'm dividing by x minus or x plus 1, let's say. Then this says that if I'll divide by x plus 1, we already know what the remainder is going to be, right? Because x plus 1 squared is x squared plus 2x plus 1. So I know that the remainder is going to be 1. But let's check it using the remainder theorem. It says that if you're dividing by x plus 1, compare it to x minus a. What's your a here? A is minus 1, right? Now your remainder is given by P of A. And what's P here? This thing. That means substitute A in place of X. Put X equals to A. So you will get -1 squared plus 2 minus 1 plus 2. So this is 1 minus 2 plus 2. And this is 1. That means my remainder is, this is confirmed by your remainder theorem that your remainder is 1, right? Is that okay?
Yes, ma'am. Yes, ma'am.
Okay. That's it.
Suppose you have given a quadratic where the value of the A, like the coefficient of the leading term, is not known. Then what is the way to find out the A coefficient?
You're saying if what A is, if this A is not given,
No,
or the A
I'm
in
just,
AX square plus.
in the equation, some AX square plus BX plus C,
Okay.
you are having equation. You know
Then you will
X,
be given.
B, X,
Okay.
yeah. You want to find out A, the leading term. There are a few
Then you will be
questions
given
related to it.
conditions, right? Yeah, there are questions like that, and you're given something, right? Like the slope of this function at this point is this. This is one condition given. Then some other condition is also given, right? So you'll be given such things.
So basically,
Between two
Px
questions
that
on
is
this.
equal to Y. Yeah,
Yeah.
that is P, Fx that is Y. So if you have the y-intercept, that is, if you got the coordinate Y, then you can find out the A like that.
Let's say you have been given y-intercept. Y-intercept of the parabola, let's say it's given to be 2. And then you've been given, let's do one thing. 1 second. Let me just make a question here. I'm making a simple one only, but fine. Let's say you have this thing. Then your question can be framed as, we know the y-intercept here is 1, right? Y-intercept is 1. Then they can give you the slope. What all is needed? Your y-intercept is needed. And then let's say slope at one point is given to be slope at x equals to 1 is 4. If these two things are given to you, and maybe we'll require another set of another piece of information too. So let's try solving this one using this. So a y-intercept is 1, right? That means your polynomial is now updated to px is equals to ax square plus bx plus 1, right? Now this is, we already know what c is. Then coming to the slope part, you have 2ax plus b equals to 4. And you'll need one more piece of information to solve for a and b. So let's say you've been given that your vertex is what's the vertex of this? It's x square plus 2x plus
2a
1, right?
plus
So
b
vertex
would be 4, na? 2a
minus
plus b
b.
would be 4.
It's -1.
You have taken 2ax.
Just one
If you're
second. We'll
putting
come to that
x,
one. We'll
okay.
need one more thing here. Vertex is, or x coordinate of vertex is -1, let's say. If this is given to you and you have to find using this set of information, this is the set of information given to you, and you have to find the parabola, right? The equation of the parabola. Then one C is already found, and you need to find A and B, right? One equation
So
is
B
this
equal to
using the slope.
2A.
Yeah.
B equal to 2A,
Okay.
so
B will be
replacing
equals
the
to
2A
-2A,
with B.
but you have -1 here. Okay. Okay. So this will be ax square. Okay. So this is, you're using
Replacing
this
2A
slope
with
at x
B.
equals to 1. Okay. Just 1 second. Slope at x equals to 1 is 4. So you will find the general slope, which is 2ax plus b, right? And at 1, it's 4. So put x equals to 1 here. So you'll have 2a plus b equals to 4. That's one equation in two variables. And then the other equation you can find from here, which is x coordinate of vertex. So if this is your vertex x comma y, then this x is given by, what is the x coordinate of your vertex? It's minus b by 2a,
minus b by
right?
2a
And it's given to be
equals to
minus
minus
1.
1.
That
So
means
b
your
equal
b
to
is
2a.
equals to 2a. This is your second equation. Now you have to solve these two equations and you'll get the value of a and b, right? That means you find the entire
So b equals to
quadratic
2
function, right? So b
and a
will be
equals to
2,
4.
a will be 4. So your equation becomes 4x squared plus 2x plus 1. So this is the polynomial then.
Yeah.
But wait, that's
Ma'am,
not
value
what we started with. 1 second. We started with this one, right?
X squared plus x plus 1. X squared plus 2x plus 1.
Yeah, just 1 second. Are you sure b is, if I'll put b is equals to 2a here, I'll get 2a plus 2a is equals to 4.
yeah,
So
ma'am.
my a will
is
be
equal to
1. A is 1 and then b will be
2.
yeah, b will be 2. So this is going to be yeah, x square plus 2x plus this same thing, x square plus 2x plus 1. The same thing that we used to form this question. Is that okay? So that's how you solve and find the values of A, B, C. You'll be given information. You just have to use that. That's it. Then we have this thing, graphing of polynomials. So one is polynomials are always continuous and they're always smooth. That means your graph of polynomials always looks like this only. It cannot have sharp turns like this. Sharp turns are not there. Then sharp abrupt turns. This is an abrupt turn, right? Where you were going here and then suddenly you moved here. So this is not going to happen in a polynomial. And then you have no breaks or sharp corners is part of this only, smooth. These two are same things. Then continuous is you won't see any breaks. You cannot have this and then suddenly it's this. This is not a polynomial. And then maximum number of turning points is n minus 1. You can have less number of turning points. Less number of turning points than n minus 1. That's possible. So if you have, let's say, x cube plus x, then the number of turning points, maximum number of turning points this polynomial can have is 2. That's it. And then for odd multiplicity, so if you have multiplicity odd, then your graph crosses the x-axis like this at that point. So let's say at 2, this is, let's say, minus 2. If at minus 2, if minus 2 is a root of a polynomial and the root, that means x plus 2 is a factor, right? Minus 2 is a root, that means x plus 2 is a factor of the polynomial. And if you see odd degree here, like 3 or 1 or 5, that means it crosses your x-axis either this way or this way, right? And if you see even degree here, if you see 4 here or 2 here, that means it's either this or this, one of these two, right? So this is for odd multiplicity and even multiplicity. And finally, we have n-term behavior. So for n-term behavior, we have, okay, this will only be understood or clearly understood if we take some example. So if you have let's say if your leading term means if you have 3x cubed plus 5x squared plus 9x to the power 9, then the leading term here is this, the term with the highest power. That's called your leading term, and you only have to focus on that term. To find the n-term behavior, only that term matters. So let's say your leading term is 3x to the power 9. Then your n-term behavior is when x tends to infinity. So if your x will tend to infinity, this entire x to the power 9 will tend to infinity, and because this is positive, so this will go to plus infinity. So when x tends to infinity, and this side is when x tends to minus infinity. This one. This end is for x tends to minus infinity. This end is for x tends to plus infinity, right? So if your x tends to infinity, the polynomial with leading term 3x to the power 9 will go here on the right side, and on the left side, when x tends to minus infinity, your x to the power 9 will tend to minus infinity, and 3x to the power 9 will also tend to minus infinity. So it will go like this. So this is when 3x to the power 9 case is there. Now next up, let's take minus 3x to the power 9. If this happens, then the things are going to change this way. And if we have 3x to the power 8 instead, now we have an even power. So when x tends to infinity, this thing tends to infinity, and 3x to the power 8 also tends to infinity. That means on plus infinity side, your graph will look like this. And on minus infinity side, when x tends to minus infinity, x to the power 8 also tends to, x to the power 8 tends to infinity, and 3x to the power 8 also tends to infinity. That means on this side, it will look like this. So your graph could be something like this, right? When both ends it's going in the upward direction. And finally, let's say you have minus 3x to the power 8. So this is going to be both downwards. Is this okay?
Ma'am, so can we tell like if it is even, then it will be on one side, like both the infinities will be on
Yeah.
one side. If it is odd, it will be on opposite quadrants.
They'll be on the opposite depending on what's the leading, if the leading coefficient is positive or negative. It depends on that then.
Okay.
Ma'am,
Okay.
repeat please.
Should I repeat this thing?
Yes, ma'am.
Okay. Let's come to this one first. Let's say you have a curve, a polynomial 3x to the power 9 plus 7x. If this is your polynomial, then the leading, first you have to understand what's your leading term. This is your leading term. The one with the highest power is called your leading term. So you only have to focus on that term. Forget everything else. Forget this. You only have to focus on 3x to the power 9 now. Now, if your x is tending to, let's check when x tends to infinity. This is the side x tends to infinity. When your x tends to infinity, x to the power 9 tends to infinity, and 3x to the power 9 also tends to infinity, right? That means when x tends to infinity, 3x to the power 9, that means your polynomial also tends to infinity. And polynomial is y, right? So that means if your x tends to infinity, y also tends to infinity. So height also increases. That means it's going in the upward direction here. And when your x tends to minus infinity this time, if it tends to minus infinity, that means x to the power 9 also tends to minus infinity. And 3x to the power 9 also tends to minus infinity. That means your px tends to minus infinity, right? Because where px goes entirely depends on the leading term. We have discussed this. Leading term decides everything. So that means this will go to minus infinity when x tends to minus infinity. Is this one clear?
Yes, ma'am.
Okay. If this one is clear, then you should be able to do the others as well. They're using
ma'am.
the same logic. Yeah.
Ma'am, if x is minus infinity, okay. Ma'am, you have taken 3x to the power 9. Okay.
Yeah.
What happen when you take x or x as minus infinity and minus 3x9?
Minus 3x to the power 9 when x tends to minus infinity. Okay. When x tends to minus infinity,
Hello, ma'am, you are
odd
audible?
powers. Yeah, you're audible. This is your doubt, right? Is this your doubt?
Hello, ma'am.
Yeah. Am I audible?
Your voice is not coming.
Yes, ma'am, you are audible.
Okay, then there's something wrong on your end. If this is I think this should be clear. You just have to
Yes, ma'am.
have a little knowledge of what happens when you have an odd power when x tends to minus infinity, and what happens when you have an even power when x tends to minus infinity. That's it.
Okay, ma'am. It's clear.
Okay. Then moving to this is, yeah.
In the end, could you please make us understand how to solve the real life problems of polynomial as given
Yeah,
in
we
the
have
assignments?
problems here.
Okay, ma'am.
Excuse me, ma'am.
We're going to do, yeah.
You missed the intermediate value theorem.
Okay. So your intermediate value theorem is, let's discuss
Hello,
that here.
ma'am.
Yeah.
Ma'am, I have a doubt. Like, I have plotted a graph in the Desmos x to the power 9 minus 50,000 x to the power 8, and it is behaving like a even degree polynomial.
X to the power 9 and what?
Minus 50,000 x to the power 8. X to the power
Okay.
8. So it's behaving like a even degree polynomial.
Even degree polynomial, and what's happening?
Uh,
The only thing you
from
can see
both
from here is when x tends to infinity, this should go to infinity, and when x tends to minus infinity, only look for the end term behavior. Just check that if your x is increasing, is your y increasing with it, and when your x is decreasing, is your y decreasing or not with it. That's all you have to check. That's it. Because the
okay,
end
ma'am.
term behavior is all about that. We don't care about what's happening here. We just care about what's happening towards the end. That's what your end term behavior tells. So in your graph, when x is increasing, is your y also increasing with it? Just check that. Eventually, here at the end, when x increases in this direction, is y also increasing? That's what you have to check. When x is decreasing on the negative side, is your y also decreasing towards the negative? That's what you have to check. That's it. Is that okay?
Okay, ma'am.
Okay. Then intermediate value theorem is basically when you have two roots. Let's say you have a polynomial, and this is valid for every continuous function, by the way. So if fx is continuous function and fa is greater than 0 and fb is less than 0. So a and b could be like this, or a and b could be like this, right? We don't know which one's greater, a is greater or b is greater. Then this says if your function is continuous and f of a is greater than 0, so this value is greater than 0. That means height f of a is basically height of your function f at the point a, right? When x is equals to a. So that means when x is equals to a, the height of the function is positive, and when x is equals to b, the height of your function is negative. That means it's here. This is f of b, this height. Right? So your point, one point is here, other point is here, and it's a continuous function. So because you have to go from here to here, so somewhere you will have to cut the x-axis. That's what your intermediate value theorem says. It says that there exists at least one x naught belonging to this a comma b such that f of x naught is 0. This is your intermediate value theorem, which says that there should be at least one point between a and b where your function becomes 0, when your function takes value 0. So you will get at least one point x naught between a and b where your function will take value 0, where the height of your function will be 0. This is height 0, right? So and it could be more than one function. It's quite possible that your function looks like this. It's possible, right? Now it's taking 0 value at more than one point. That's why I said at least you will get at least one point. There could be more than one points though. That's your intermediate value theorem. And we have written A, B or BA because we don't know which one's greater. Is that okay?
Yes, ma'am, got it.
That's it. That's your intermediate value theorem. And let's come to the questions then. So this is the first question. It says This is a given function, and you have to tell which of the following statements is correct. Let S is equals to the points. So this is a set of, what is this? This is set of zeros, not real zeros. This is set of all zeros, including the complex ones of fx, right? Where x may not be real, then ns is equals to 0. So this one says that this is a set of all polynomials, and this includes, let's say, if you have x squared plus 1, then it does not have any real zeros, right? No real zeros, but I have a 0 iota and minus iota. These are complex zeros of this polynomial.
No, ma'am, first of
We don't have real zeros. So in this case, if you will take this one, then this S set will be equal to iota and minus iota. Where x may not be real, then ns is equals to 0. But this is not 0, right? It simply is testing that whether you know or not that there could be zeros that are not real. Non-real zeros is the concept that it's trying to test. So this is incorrect. Then
Could
the
you
number of
please
x.
explain it again?
Okay. The option says, let's say you have a polynomial. You have been given a polynomial, right? Or, okay, this is about this given polynomial. I thought we have to take any random polynomial. Okay. If this is your polynomial, then what are the roots of this polynomial? This is x squared plus 5 equals to 0. And then x squared plus 4 is equals to 0.
Plus or
There are
minus
no
root
real
5i.
roots.
Is equal to
I
plus
root
or minus
5.
root 5.
I root 5.
Okay.
I
This will be
Iota. Iota
root
root 5.
minus 5, but it will be 5 iota, right? So this is 5
Yes.
iota, and this one will be not
4
5 iota. This will be
Plus
root
or
5
minus.
iota. And this will be 2 iota, right? Plus
2 iota.
minus. And here also you'll get plus minus. So the roots are root 5 iota minus root 5 iota, then 2 iota and minus 2 iota, right? These are your roots. So your S set is equals to this, right? It's the collection of all the points where your polynomial fx becomes 0. So these are the points where it becomes 0, but none of them is real, right? Then this is basically this is the notation for number of elements in S. Basically the cardinality of S.
Yes.
So this is S, and the cardinality of S is not 0, right? That
4.
means this is incorrect.
Okay,
Then the
ma'am,
number of
noted.
x intercepts. Okay. The number of x intercepts of this function is, so
I think
this is
false.
incorrect because x intercepts are the real roots of your polynomial. So if you have a polynomial,
Yes.
only the real roots are x intercept. The imaginary ones are not x intercepts because they are imaginary, so they can't be plotted on x axis, right?
Here
X
D
axis
is
is the real
less than
axis.
0.
Okay. X axis is a real axis, so you can't plot non-real numbers. Root 5 iota is a non-real number. You can't plot it here. That's why it's not an x intercept. So this is incorrect. Then S is equals to the same set where
True,
x may
ma'am.
not
True.
be real.
Option C.
True.
This is
True.
correct.
True.
This is true, right? Then the number of x intercepts for this function is
True.
0. This is also
True.
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 And if in case you had here, let's say, if your set were this 2, then the number of x intercept would be 1, right? Because we have one real root.
Yes, ma'am.
So the number of x intercepts
Yes,
would become
ma'am.
1. Okay. Then coming to this one. This is a long question. We're not going to read this entire question. This is all about the radius of the circular region, which is hx. This is the radius. We have a circular region whose radius is given by this. The side of the square. This is side of a square given. Assuming every point in the square is equally likely to be the landing point. The probability that the astronaut lands safely in the green region is given by this. This is the probability. So you have to find the area of circle with radius this and area of square with side this. You don't have to read this entire thing. But ideally you should be reading everything, but we don't have to in this one. find the roots of px. So you have to find the roots of px. What's the area of circle with radius? This. So area is pi r square, right? So it should be pi hx square.
By
And then
area
area of
square.
square is side square,
Side
right? So
square.
mx square. So this is going to be equal to, can we find the roots of this one? This mx square is going to be pi x minus 1. But I don't want this to be multiplied. Let's do one thing. Minus 9x plus 9. And this same thing repeated again. We have repeated this here. So you have to divide this whole thing by just, and we have pi here, right? So pi gets cancelled. And then you will be left with, so you just have to perform division now. So you will get 4x cube minus 4x square minus 9x plus 9. You can, by the way, you can directly take 4x common, 4x square common from here. So you will have x minus 1 from here, from these two. And then from here, you can take 9 common. You will have x minus 1 here. So this is 4x square minus 9. You don't have to, if you want to perform division, you can. But otherwise, we directly have the answer, right? So this is it. That means you have 4x square minus 9, x minus 1 here.
Into
And then this hx polynomial multiplied again. You can take squares here if you want to. And this is, you have to divide by x minus 1. So this is going to become this. So this should be your answer. And you have to find the roots of this px. So what are the roots of this? This is px, right? You have to find the roots of this. So the roots are x is equal
Plus
to
minus 3 upon 2.
plus minus 3 by 2 and 1.
yes.
So these are your roots. Can we move to the next question?
Ma'am, the root can't be 1 as we have cancelled one factor,
Ma'am, we
x
have
minus 1.
cancelled the x plus 1, no? X minus 1.
We had two, okay. This when factorized, this is your polynomial hx. So when you factorize hx, you will get this, right? And we had to take h square x. That means we had to square this thing, right? So we'll square this and we'll square this. And then in the denominator, you have x minus 1. So one gets cancelled and the other is still left, right? One x minus 1 got
okay, ma'am,
cancelled.
okay.
The other one
Yeah,
still left. Okay. So this is the next question. It says x plus a minus 1 is a factor of this polynomial. You have to find the value of a. So if this is a factor, then we have done factor theorem. What should happen then?
Is equal to f of a minus 1.
What?
If x plus a is a factor of p of x, then remainder is equal to f of a.
X, not x plus a. It was x minus a. If x minus a is a factor, then p of a was 0, right? So here you have x minus 1 minus a. This is a factor of px. That means if I'll take this 1 minus a, this should be 0, right? So I just have to substitute x equals to 1 minus a in this polynomial, and that should be 0. That means 1 minus a square plus 4a minus 7, 1 minus a plus 2a square minus 7a plus 5, and this thing should be 0. And then everything else is, you have to find the value of a. So this is 1 plus a square minus 2a plus 4a minus 4a square minus 7 plus 7a plus 2a square minus 7a plus 5 equals to 0. So a square terms are these. So this is minus a square. Then a terms are these. This is 2a. And these two get cancelled, right? So you'll have plus 2a. And then the constant terms are these. 1 minus 7.
1.
This is minus 7, right? This is not 1. This is 5. So, okay.
Total will be
Okay,
Total
that
minus
is minus 1. Okay, okay. This is minus 7. Okay. So this is 0. Now, if you solve this, this is simply just a square minus 2a plus 1. It's the square of this, a minus 1 whole square. If you cannot directly see that it's the square of a minus 1 whole a minus 1, that's also fine. You can use the quadratic formula and then find the solutions. You will get a is equals to 1. Is that okay?
yes. Yes, ma'am.
Okay, can we move to the next question?
Yes.
This is the next question. So this is about, I think we've done a similar question in class, right? Okay. So this is when a polynomial Px yields a remainder of 3 when divided by x minus 1. Let's say this is your polynomial. It says when you divide it by x minus 1, use division algorithm x minus 1 qx plus remainder, right? Remainder will be a constant because this is a linear polynomial. That's why your remainder will be, remainder's degree should be less than this, right? So your remainder has to be a constant. And remainder is given to be 3. Let's call it R1. And then you have Px when divided by x minus 2. Let's call it Q2x. And this is 5. Right? So, and then you have x minus 1 and x minus 2. So if you have x minus 1, x minus 2, let's call this Q3x plus some polynomial, let's call it R3x. Now, first thing that you have to notice is what's the degree of the remainder here? If this is your divisor, then what should be the degree of Rx? R3x.
1.
1.
Okay. 1, but from here we only know that it should be less than 2. It can be 1 and it can be 0 too, right?
Yes.
Why?
Yes, ma'am.
So there are two possibilities. Either it has degree 0 or it has degree 1. So you'll have to check which one of this is not correct. So if you'll take degree 0, that means it's a constant one. That means your remainder is constant, right? But if my remainder is constant, then it's varying here, right? Just 1 second. If I'll put 1 here, what's P1? 3, right? Put 2 here, you'll have P2 is equals to 5. And these are remainders, right? P1, P2 and all give you remainder when divided by x minus a or whatever. So if you have this thing, we already know that this is a remainder, this is a remainder, and your remainder cannot be constant. If degree is 0, this implies remainder is constant. But remainder is not constant because your remainder is varying here, right?
Yes. Yes, ma'am.
So that's why this possibility is eliminated. That means the degree of your polynomial should be 1. So the only possibility that you're left with is that your degree, the remainder's degree is 1. That means your remainder looks like this. Degree 1, remainder is a degree 1 polynomial. So it's this, ax plus b, right? Now if your remainder is ax plus b, and here you have R1, this P1 is equals to R1. Now if I'll put P1 here, if you look at these things, P1 from here, Okay. I don't think I need to explain that part. It was about this. Why R11 is equals to R31. It was about this. These two are different polynomials, different ones, right? But R11 is the same as R31, and similarly R22 is the same as R32. So only for these two, only for one point R3 and R1 is same, right? And only for 2 point R2 and R3 are same. We used the fact that R3 is not a, this is not a constant, right? To show that the degree is not zero, we use the fact that this is not a constant, because if it were a constant, it cannot take two values. But this R3 is different from these R1 and R2. But R31, so how do you show that R3 is taking two values? Because R31, put 1 here, you will get R31 equals to R11, right? Because it's equal to, put 1 here, 1 here and 1 here, you will get R31 equals to P1, right? And P1 is the same as R1. Here is how you get that R3 is not a constant polynomial, because these two are taking different values. Otherwise, they were different. Okay. So this looks like AX plus B. And we already know that R1 of 1 is the same as R3 of 1, right? And what is R1 of 1? It's 3. And that means R3 of 1 is, so if I'll put 1 here, I'll get A1 plus B is equals to 3. Similarly, if I'll put, similarly, if I'll put 2 here, I'll get 5. Now you only have to solve these two equations. Solve these two equations and you'll get the values of A and B. What do we get
A
from
equals
here?
to 2 and B equals to 1.
That means your remainder is 2x plus 1.
2x plus 1.
This one then. Okay. Let's move to this one. This is the next question. It says the zeros of, does anyone have a doubt so far?
Yes, ma'am. In this question that, ma'am, could you please explain again how R3x could only be 0 or 1? Like, why are those two the only options?
Okay. R3x, not R3x, degree of R3x. We know that if you are dividing this polynomial, if this is your divisor, then we've already studied that the degree of remainder is strictly less than degree of divisor, right?
Yes, ma'am.
Or your remainder is 0. But our remainder is not 0. Either your remainder is 0, or let's test that too. Let's test why remainder is not 0. So what are you left with? We're left with three possibilities. Either your R3x is 0, or degree of R3x is 1, 0 or 1, right? So if the degree is 0, that means it's constant, right? That means R3x is a constant. If
Yes.
your and if this happens, that means your R3x is a linear function. That means AX plus B types, right? We have already seen why it cannot be a constant. Why? Because R31, have a look here, R31 is the same as, put 1 here, you will get R31 equals to P1, right? And P1 is the same as R1 from here. That means your R31 is the same as R11, or you can simply write R1. And what's R1? This remainder is 3, right? So R31 is 3. Similarly, R3 at 2 is 5. And this cannot be constant, right? This is a polynomial, it's taking two values.
Yes, ma'am. Yes, ma'am.
That means it's not a constant polynomial. So we have eliminated this factor. This cannot be possible. So that means it's either a linear function or it's a 0 function, right? Why can the remainder not be 0? So if I put 0 here, then that means
We wouldn't get a reminder when
yeah, if you'll put 0 here, if R3 is 0, that means R31 is also 0, right?
Yes, ma'am. Understood.
But R1 is not 0. That's the problem. So you will get
Understood.
contradictions there. That's why this is also not possible. So that this is the only possibility that you have.
Okay, ma'am. Thank you.
Okay. So can we move to the next question?
Yes, ma'am.
Okay. So this is the next question. And it's easy too. So the zeros of this is a polynomial given to you where qx is not known. And they say that the zeros of this polynomial are 2 by 3, -1, 4, and -5, each with multiplicity 1. And if the leading coefficient of qx is 1, then you have to find q2, the value of q at 2. So what are the zeros of from here, from these two? From here you get the
2
zero,
by
x is
3
equals to
or
2 by
minus
3.
1?
From
Ma'am,
here you get,
-14 is the answer.
okay, let's see. X, from here you get x equals to 2 by 3 root. Then from here you get x equals to -1 root. So these two are already covered. And it says px has roots 4 and -5 as well. That means if 4 and -5 are roots of this and they're not the roots of this, that means the roots of qx, right? So the roots of this are 4 and -5. And if qx has two roots, 4 and -5, and qx
Minus
cannot have,
14.
I don't know the answer. I'll have to check. Okay. So if qx has only two roots, because only two roots are left here, that's why qx can only have,
X minus 4
I'll
into
I'll
x
alter
plus
the
5.
question and then we'll see how else can this question be changed, because it's in the easiest form right now, right? So right now you can clearly see that qx should be equal to x minus 4 and x plus 5 with a constant. We don't know what that constant is, but this says that the leading coefficient is 1, right? That means your k, what's the lead?
Is 1.
If I take k here, then the leading coefficient is k, right? That means k should be equal to 1. That possibility is also gone. Let's say if they said the leading coefficient of qx is 9, then you should have taken 9 here, right? Then this will become 9. So your qx would be this. And then you're asked to find the value of q at 2. So you have to put x equals to 2 here. q2 is 9, 2 minus 4, and 2 plus 5. That's it. That's how you have to solve. Now let's say if instead the multiplicities are changed a little, let's say instead of taking multiplicity 1, it's given that the multiplicity of this is 1, this is 2, this is 3, this is also 2, let's say, and this is 1. Now what does this mean? Now things are going to change. This will mean one multiplicity is 2 by 3 as multiplicity 2. And one multiplicity is consumed here in this factor. That means one multiplicity is still left and this will go here. That means you will have x plus 1
3x
here.
minus 2.
X for 2 by 3 you will have x minus 2 by 3.
X plus 1.
Then for this one, again one multiplicity is
X plus 1.
consumed here. So you will have x plus 1. And then you will have x minus
X
4 to the power
for
3.
cube.
Right. And x plus
And
5 to
x.
the power 1. That's it. That's how this is supposed to be
Yes.
done. And leading coefficient, you have to use k here. And if they say leading coefficient is 1, put k equals to 1. If they say leading coefficient is 7, then put k equals to 7. Is that okay?
Okay.
Yes.
Okay. Then coming to this question. This is the next question. It is given that the quadratic function x square minus x minus 2 is a factor of the polynomial this. Find the value of a minus b. So x square, what are the roots of x square minus x minus 2? Let's see the roots of this first. Let's break it down into two linear factors. So this is
Ma'am, -2 and 1.
So it will 2
right.
and minus
So
1.
2 and minus 1 will be there then. The
Sorry,
roots are
same
2
answer.
and minus 1. So
X minus 2.
this is it, right? Minus 2.
Yeah, ma'am. Yeah, ma'am. It is.
Okay, it's this. So these are going to be your factors, and this says that now if this says that this divides, it is given that this quadratic is a factor of this. That means x minus 2 is a factor of this polynomial, and x plus 1 is also a factor of this. So let's go one by one because that will be easier, right? So if x minus 2 is a factor of this polynomial, then p of 2 should be 0, right? And similarly, p of minus 1 should be 0.
What is 0?
What's p of 2? So p of 2 is 2 to the power 4, which is 16, then 8a, then 4b. I'm just substituting x equals to 2 here, that's it, in p. 4b minus 8 plus 4, right? This will be 0.
It will come 8a plus 4b equal to minus 12.
8a plus 4b equals
Equal to
to
minus 12.
okay, then this then is going to be equal to 2a plus b equals to minus 3. This is one equation, and that the other equation you get from here, p of minus 1 is 0. So if I'll put x equals to minus 1 here, I'll get 1
minus a plus b plus 9 equals to 0.
minus a plus b
Plus b plus 9 equals to 0. No, so plus
plus
b.
4
Sorry, plus 4.
and plus 4 again, so it's 8, right? And this will be 0. So
It
this
will
is
be
minus
a minus b is equal to 9.
मैम a minus b equal to 9 आ जाएगा सीधा.
Okay. So this is a minus b equals to 9. And now you have two equations. One is this. The second one is this. This is 9.
Ma'am, we directly got the answer. A minus
don't
we have
need
taken
it.
a minus b
A
only.
minus b.
A minus b is equal to 9.
Okay, so
Yes, the value is 9.
that's what we have to find. Okay. Even if you're asked to find the individual values or you are asked to find a plus b, you can just find a and b individually and then add them. Okay. Can we move to the
Okay.
next question? This one.
Yes, ma'am.
So which of the following are correct? Every zero polynomial is a constant polynomial, but the
No,
converse is
false.
not true. So zero polynomial is a constant polynomial. Why is it false? Zero polynomials are
Ma'am,
constant
zero
and the
polynomial
converse is
has
not true, right?
Yeah.
yes, ma'am.
So this is right then. Zero polynomial is a constant polynomial, but a constant polynomial is not always a zero polynomial. This is correct. Please read the statements carefully and then answer. Okay. The point of intersection of the curve y square is equals to 4x and y is equals to x square by 4 on xy plane is 0, 0 only. So your
Ma'am,
y,
this is false.
let's see. I have a habit of checking things graphically. So if you have y square is equals to 4x, it's supposed to be like this. And if you have y is equals to x square 4, it's supposed to be like this. But because they are functions, so this branch is not there. This one is y square is equals to 4x, and this one is y is equals to x square by 4. And we have 2 points of intersection. One is here, 0, 0, and we have another point of intersection in on the xy plane, right?
So it is false.
So this one's false. And if you want
How
to
can we
find the
check without graph?
okay, without graph, what you can do is you can take y is equals to square root of 4x. This will be plus minus square root of 4x. So one time you can take square root of 4x. Other time you can take equate this to x square by 4. Find y from here, equate it to the y of this one. Is that okay? So the y from here will be root 4x and minus root 4x. Then equate root 4x to x square by 4 and equate minus root 4x to x square by 4. Now, if you look at this thing, we know that square roots are positive. So this value is always negative. This value is always positive. This is never going to happen. You don't have to find the root of this one. That means you're only left with this. Find the roots of this. So to find the roots of this, you can directly square it on both sides. You will get 4x is
8.
equals to x4 by 16.
4.
And this is, you're going to get two roots from
And
here.
x equal to 4.
One is x equals to 0 and the other will be x is equals to 4. For this, to solve this, you can take x to the power 4 is equals to 64x, or you can take x to the power 4 minus 64x equals to 0. Right? And so the two roots here are, and then you can write this as x minus x cube minus 64 equals to 0. Wait, how are we getting 4? Just 1 second. This is the equation, right? Then you will have x equals to 0 from here and x cube is equals to 64. And 4's,
And 4's cube is 64.
okay.
Yeah, ma'am.
Oh, they are right. Okay. So this is going to be x equals to 4 and x equals to 0 by solving this. That's it. Is that okay?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Next up, we have this question. The quadratic function ax squared plus bx plus c has a minimum value of minus 4, which occurs at x equals to 2. And the minimum value is given by
Minus b by 2.
minus b by, there are two things given. It occurs at x equals to 2 and the minimum value is minus 4. That means this is equals to minus 4 and this is 2. Right? So these are the two things given to you, and then you're given f of 0 is 8. If f of 0 is 8, this is f of x. That means f of 0 is c and it's given to be 8. That means your function, this quadratic function becomes ax squared plus bx plus 8. This is one thing. Then you've been given that your minus b by 2a is equals to 2. That means b is equals to minus 4a, right? This is one thing. Let's call it equation 1. Then you've been given f of minus b by 2a is equals to minus 4. So if I'll put minus b by 2a here, let's put x equals to minus b by 2a here. What's minus b by 2a? 2, right? So let's put 2 here. A 2 squared plus b 2 plus 8 equals to minus 4, right? This is fx. All I've done is I've substituted x equals to minus b by 2a, which is given to be 2. So I've substituted x equals to 2 to get the minimum value, which is given to be minus 4 here. So if I'll solve this, I'll get 4a plus 2b is equals to minus 12. Or 2a plus b equals to minus
So
6.
A equals to 2.
Answer is minus 1. ma'am.
Okay. So these are the two equations given to you. You just have to solve these two equations. Put b is equals to minus 4a here. You will get 2a minus 4a is equals to minus 6. So this is a is equals to 3, right? And b
A-
then will be equal to
Minus 12.
Yes, ma'am. B minus 12.
minus 12. And what's asked in the question? You've been asked to
plus
find
B.
the value of
A plus B
a
plus C.
plus b plus c. So it's 3 minus 12 plus 8.
Minus 1.
Minus 1.
Is this one okay?
Yes, ma'am.
Yes, ma'am.
Okay. Then next up we have this question. This is based on intermediate value theorem, and I think we've discussed a similar question in class. So we'll take that up later. Let's do this one first. So this is, you've been given this polynomial and you've been asked, let's first try to plot this polynomial and see if we can plot it or not. So this is, your polynomial is given to be minus x or minus x minus 5 and x plus 5, right? I have written x square minus 25 as x minus 5 and x plus 5. And then you have x square minus 9. So this is x minus 3 squared, x plus 3 squared. And then you have 2 minus x square. And then we have x plus 9. Is this okay? This square is outside. So now we have linear factors and their powers. So we have written px in terms of linear factors and their powers. So what are the roots of px? Roots are 5. Let's start from the negative side. So the most negative one is minus 9.
Minus 9.
Then we have minus 5.
5. Minus 3.
Then 2.
3.
Then 3.
5.
5.
5.
Yes,
So
ma'am.
these are the
Ma'am,
roots.
ma'am,
This
5.
has multiplicity 1.
Ma'am, may you please multiplicity?
What?
Multiplicity, how minus 9 is 1?
Minus 9. This is, okay, we have another.
Ma'am, because minus 9 is occurring one time, that?
Yeah. Yeah, because this is one time. It's only one time, right? Do we have it more than one time?
No, no.
No,
That's why
right?
it is 1.
Yeah.
Multiplicity.
That's why it's 1. Then we have a multiplicity of minus 5. That's also 1. Then we have multiplicity of minus 3. This one, which is 2. Then we have multiplicity of 2, which is again 2. Then multiplicity of 3, which is again 2. Multiplicity of 5, which is 1. Right? It has 9 degree, right? 4 from here. 5, 6, 7, 8, 9, right? So these are the multiplicities. Then coming to plotting them, let's say you have minus 9 here, then minus 5, minus 3, 0. 0 is not a root though, but we are still using it here. 2, 3, 5. So starting from here, starting from minus 9, because minus 9 has multiplicity 1, that means it's either this way or this way. That's how your graph looks here, right? Either it will look like this or it will look like this. So what's the end and what's the end term behavior? When your x tends to infinity, where does your px go? You can use this thing. So if your x tends to infinity, this will be positive, this will be positive, this will be positive, this is again positive, positive, and this is also positive. So when x tends to infinity, all of these are positive, but the ultimate sign here is negative,
Yes,
right?
ultimate 9.
So
Negative.
it will be minus infinity because of this sign.
Yes, ma'am.
So, and then let's take when x tends to minus infinity. When x tends to minus infinity, this will go to this, everything will change here now. When x tends to minus infinity, this goes to minus infinity, this goes to minus infinity, this goes to plus infinity, this goes to plus infinity, this goes to plus infinity, and this goes to minus infinity. So minus is 1, 2, 3, 4 number of times. That means
All over plus.
this is going to plus infinity. So that means when x tends to infinity, your graph ultimately looks like this. X tends to infinity, px also tends to infinity. And when x tends to minus infinity, px tends to infinity again. So this, right? And if your graph is like this, that means, and we have two choices here, right? Either it will look like this, or we said it will look like this. Now we can't take this, because if this happens, then that means your graph is going to minus infinity when x goes to minus infinity, which is not true. So we'll have to take this thing.
Ma'am, the graph will end in fourth quadrant.
In fourth quadrant, how? When x tends to infinity, okay. Px is tending to minus infinity, right? So, and we have, and this will cross here because the multiplicity of 9 is 1, so it's going to cross. Then we'll turn back because we have a 0 here. And at 5, again the multiplicity is 1, so it will go here. Then at -3, we have multiplicity 2, so it will go like this. Then at 2, you have multiplicity 2. That means it will go like this. Then at 3, you have multiplicity again 2. That means it will go like this again. And then at 5, you have multiplicity 1, so it will go like this. Is this okay?
Yeah, ma'am.
Yes, ma'am.
So that's your graph. And for the turning points, to check whether there are these number of turning points, because we've already, I think we've discussed this in lecture 2, that if you have something like this, then we always have an uncertainty that maybe this is also true. This could also be the graph, because we don't know what the turning points are, right? We don't know exactly how many turning points are there. We just know that they have to be less than or equal to n-1. So let's test the number of turning points here. 1 here, 2 here, 3 here, 4, 5, 6, 7, 8. So it has 8 number of turning points, and the degree was 9. And the maximum number of turning points it can have is 8, and we already have 8 number of turning points. That means this is roughly how your graph looks like. Is that okay?
Ma'am, can you please
ma'am.
explain
Explain
more
the
how you
end
got that
behavior of this
multiplicity,
again.
like how the graph is tending towards infinity and minus infinity for this question?
N-term behavior. You have a doubt in N-term behavior?
Yes, ma'am.
No, we have to just consider the term with the highest degree and go with that, right?
Yeah, you
What
have
is
to
the
consider
leading
the highest
coefficient
degree.
in this?
But what's okay, if you want to find the leading, if you don't want to do it this way, you have to find the leading coefficient. Then the idea is you have x square here, right? So if you multiply all the x's, you will have x to the power 9, right? And a negative here. Is this okay? Or do you have, yeah, this is what's going to happen. You will get an x square from here, x from here, x to the power 4 from here, x square from here. These are the highest terms from here. From this factor, the highest term is x square. From this one, it's x to the power 4. From this one, it's x square. From this one, it's x. And the leading one is -1. So it's x square, x to the power 4. So this will be minus x to the power 9. If you're not comfortable with this one, you can do it this way. The leading term will be minus x to the power 9.
How
Is
do
that
you
okay?
calculate without this?
So without finding the leading term?
Yes, ma'am.
Okay, without finding the leading term, you just have to substitute. You have, let's say you have x minus 5, x plus 5, and then you have 2 minus x square. Should I write the entire thing again? Okay. X minus 3 square, x plus 3 square, and x plus 9, right? Now, if your x tends to infinity, where does this factor go? If x tends to infinity, and we have a negative sign here, right? X minus 5 also goes to infinity, right? Look at this, like x keeps increasing. 1, 2, then 1,000, then crores, when it keeps increasing, that means x minus 5 is also going to infinity, right? So when x goes to infinity, this goes to infinity. This also goes to infinity. This also goes to infinity. This one too. This one too. And this one too. But you will be confused in the negative one. Should I explain the negative one too? If you have minus infinity here, then this goes to minus infinity. This goes to minus infinity. This one goes to plus infinity because we have a square here. Then this one goes to Again, x goes to minus infinity, so x minus 3 goes to minus infinity, but the square of it goes to plus infinity. That's why this one goes to plus infinity, this one goes to plus infinity, and this goes to minus infinity again. So it's minus infinity into minus infinity into minus infinity into negative, which will give you plus infinity. Is that okay?
Yes,
So the entire thing will go to plus infinity. That's it.
Ma'am,
Yeah.
ma'am, you have done the number line. In number line, we do that from right to left, plus minus as well sequence wise. So in graph, it's not preferring. It's giving different answer, and that's giving different answer. Because if we start from 5, this gives plus. It means it will be increasing, but here it's going decreasing function in the graph.
Okay, if you'll take something greater than 5, let's test it. Let's take 10. 10 is greater than 5, right? Let's put 10
Yes,
here.
ma'am.
If you'll put 10 here, this will be positive, 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 and this will be positive as well. And this is negative, right? That this one is left, it's negative. That means at 10, your value is negative, which is consistent with our
Sorry,
graph.
ma'am, sorry. I have mistake. I have mistake the final my negative.
Okay,
in the
you
sequence.
forgot this. That's okay.
Yes, ma'am. Yes, ma'am. Thank you.
Okay, so in minus infinity to minus 9, where's our graph? Minus infinity to minus 9 is here, infinity here, minus 9 here. It's decreasing, right? From left to right, you have to see from left to right, it's
Yes.
decreasing. So that means it's decreasing here. This should be correct. Then from 5 to infinity, here, 5 infinity is here. From 5 to
Decreasing.
infinity, it's decreasing again. So this is also correct. The number of turning points. Now this is
8.
and we don't have that option here, but it should be 8 here. Then this will become correct. Number of turning points are these 1, 2. We've already found that there have to be at least 8 number of turning points. So from this graph, we get at least 8 number of turning points. And we already know that at most the number of turning points could be n minus 1, right? That
Yes,
means
ma'am.
it can be 8. So it's at most 8 and at least 8. That means it's exactly 8. Is that okay?
Ma'am, can you repeat how to check number of turning points?
N minus
Okay.
1 degree.
Your number of turning points, maximum number of turning points your polynomial can have is maximum number of turning points is n minus 1, right? And we already have 8. So the degree of this polynomial is 9. So the maximum number of turning points it can have is 8, right? That means the maximum number of turning points can be 8. But from the graph we have drawn, we already see that it has to have at least 8 number of turning points, right? Can I remove any turning point from here?
No, ma'am.
That means we at least have 8 number of turning points. And this says that I have to have maximum number of turning points are 8. And this says, graph says, minimum number of turning points are 8. That means your turning points should be exactly 8, right?
Excuse me, ma'am.
Yes, ma'am.
Yeah.
Yes, ma'am.
If we don't know the roots exactly,
Yeah. If what was your
then
question?
turning points can be 4 also.
If you don't know the roots, any polynomial with degree n can have, let's say you have degree 9. The only thing that's given to you is the degree of px is 9. Then your number of turning points can be 4. That's correct.
Okay, ma'am.
Okay.
Ma'am, maybe leave now.
Yeah, you can leave. This is maybe the last question left. I'll discuss this one more question and then we'll end the session. And the ones who want to leave, who already know this, they can leave.
Ma'am, I have a
Okay.
doubt. This question.
In this question?
No, ma'am, the previous question.
Yeah.
Now, when you drew the graph, how did you know that you had to start from infinity and then to minus infinity?
We started from here, right? Minus infinity side, right?
Yes. So
You
how
can
do you
start
know?
from plus infinity too. That's okay. You can start from any side you want. Either start from here or start from here.
No, like, how do you know you have to draw from top and then to the bottom?
Okay. You're saying that how do we know that it's like this and not this, right? Because when x tends to infinity, when x tends to minus infinity, my px tends to infinity, right? That means
Oh,
when x goes to minus infinity, px is going to plus infinity. That means it should be this. The tail should be here, not here, right?
okay, understood.
Okay. This is the last question. Consider two polynomials. These are the two polynomials. Now, if x tends to infinity, the leading coefficient, the leading term for px is minus 2x to the power 5. If x tends to infinity, px tends to, this tends to infinity, and this is, we have a minus here, so px tends to minus infinity.
Minus infinity.
And if x tends to minus infinity, do we have that? Yeah. If x tends to minus infinity, your
Option B is
px tends
correct.
to
It tends to infinity.
Positive.
plus infinity.
Hmm.
That means this is correct, this is incorrect, and the polynomial px plus qx has even degree. So this is
No,
px,
what degree?
No, ma'am.
Odd degree.
Odd degree.
so it has an odd degree, this is incorrect. And then the maximum possible turning points of points in the graph qx is 3. So
Yes,
qx
true,
is,
true.
okay, so it's only asking about maximum. Yeah, then that's fine. Is that okay?
Yes, ma'am.
Yes, ma'am.
So we're done with the questions from week 3 and 4. If
Ma'am, I
anyone has
have
a,
a few questions. Can I
And
ask?
there is a one question left. Are you saying that?
yeah, that's, yeah.
Ma'am, where
wanted to
can we
ask you
find the
something.
live sessions, ma'am? Is there a separate link, ma'am? Because I typed it, but I could not find the live sessions. Is there a specific link to it
Where did you try? We
in
have a
the,
BS data science channel. All the lectures should be there.
what is the name of the channel, ma'am? BS Data Science.
Can someone drop the link of that channel here?
Excuse me, ma'am. I want to
Yes.
request you something.
Yeah.
Ma'am, could you please talk to the team to extend the deadline for week 5 as we have to prepare for the qualifier exam and we don't have enough time to watch the lectures. So could they please extend the deadline for 2 or 3 days?
Week 5 GA, right?
Yes, ma'am,
Yes, ma'am. The
because
deadline is 22.
19th on 19th is the qualifier exam and after 2 days is the deadline for week 5. So could they please extend so that we can
Yeah, we'll
complete
extend
it?
that. We'll extend
Okay,
that.
ma'am.
Okay.
Thank you so much.
Excuse me, ma'am.
Yeah.
I sent you a photo in the chat section. Can you check it?
Just 1 second. Yeah, so what's your doubt?
This is a wrong statement, right?
Which of the following is the parabola whose vertex is -3? Okay, so if you have to find the
Ma'am, this equation is not a
let me just
parabola
write,
equation.
it's a parabola, but it's not a function. It's still a parabola. Okay. Can you dictate the equation given to me?
Vertex of a parabola.
It's y square minus,
How
what is it?
x square and y square is both parabola? Can you read the
Okay,
equation properly?
I can read the equation properly. Uh, these type of functions, kx square and y square is equals to kx. Both are parabolas.
Ma'am,
This is
there is
also a
both side
parabola.
square.
This is,
Please check.
it's, okay.
It is not a parabolic function, I think.
Y square minus 4 by 3 and 7 y square minus 4 by 3, and what's the other side? X plus
X plus 3 whole square.
7 into
7
x plus 3
times.
whole square.
7.
This is it, right?
How it
Ma'am,
be
include the
parabolic
parabolic
function?
equation.
It's actually, this is not, yeah, this is not a parabola. If you
Yes.
y square
It
minus
is the
4 by
equation of
3,
circle.
what? 7, when you have x square, no, it's not an equation of circle either, because you have x square as positive and y
It is
square as,
hyperbola.
it's y square minus x square, so it's not a equation of circle either. It's a equation of hyperbola, and you don't have hyperbolas in your syllabus, so there has to be an error. Maybe either this square needs to be removed or this square needs to be removed. Then it's a parabola. Is that
Yes,
okay?
then it is.
Okay. That's a
Ma'am,
misprint. Yeah.
ma'am, I had it out.
Yeah.
Because this statement, we have to find all the true statements. It's multiple select. And one of the statement was if two different quadratic equations have the same discriminant, then the
We
roots of
discussed this yesterday. We discussed the same question yesterday.
Yes,
You can check
I
it in
asked
the
that
lecture.
doubt. You don't see the lecture after
You can watch
10.
it on YouTube. That's fine.
Yes, 10:30 p.m. After 10:30 p.m. that will be discussed.
okay, ma'am.
Ma'am, I have a doubt.
I have one, just one more question.
Yeah.
Ma'am, this has a figure. I don't know how to show you right now.
You can share the image in chat box.
Okay, ma'am. I'll after I send the image, I'll prompt again.
Okay. Okay.
Ma'am, I have a question. Can I ask?
Yeah.
Ma'am, in week 2, last class, it says that SSC and some square error. I can't understand. I understand some square error, but I can't apply how to find the sum square error answer. Can you give the example and can you understand one sum square error question?
Okay. Sum of square errors is basically, let's say you have a function given, and so there are two things. One are the actual values or the recorded values, like in experiments we do, right? So
Yes, there is a
recorded
table
values.
given.
Recorded values are the observed values that were observed by people, and these are the values over the function. So you have been given two values. One is, let's say this is 2, 3, 5, and then this is given to be 1, 4, 7. So this is as per the graph or as per the function. These are the values as per the function, and these are the recorded values. Like let's say at x equals to 1, the recorded value is 2, but as per the function, that means f of 1 is 1. Or at x equals to, or let's take a particular function, that will be better, right? Let's take x plus 2. Now the value at x plus 1, as per this function, is at x equals to 1, as per this function is 3, right? This is 3. At x equals to 2, the value is 4. At x equals to 3, the value is 5, right? And let's say your recorded value is this. That means as per some experiment or some observations, these are the observations. So your sum of squared errors is basically, you have to take the difference of these. Take the difference of these and square the difference. Take the difference, square it and add it. That's it. This is your sum of squared errors. Is that okay?
Yeah. Ma'am, you have given that equals to 0.
I have sent the
What?
figure question.
It
Which
will be
figure?
equals to 0. No, ma'am, you have given that final equals to 0.
It is should be
No, this is
2.
this is your sum of squared errors.
Okay. Okay,
Okay.
ma'am.
Okay.
Ma'am,
Yes,
I
ma'am.
have shared the question to you, ma'am.
Ma'am, I am shared the question in chat box. Please solve.
Okay. Yeah, what about this question? What about the graph? I see the graph. What's your doubt?
Ma'am, in this question, one of the options was that multiplicity of -1 and 1 must be the
Hmm.
same. And ma'am, but it's supposed to be true, right? But in the list of correct answers, it was not marked.
Okay, so your graph is something like this. At -1, because both the graphs look the same at -1 and 1. And this one says it must be, right? So if it says can be same, then they can be same. That's right. Because they look the same here, right? So from here, from what I see, it looks like the multiplicity of both of the roots -1 and 1 is 1. But you
Yes, ma'am.
cannot simply say it by looking at it, right? Let me just have a look at the picture again.
Yes, ma'am. But the thing is, since it's passing through the horizontal axis, so it must be having an odd multiplicity. So if it's not 1, then it should next possible one is 3 or 5. So if it was in that case, the graph would be
They look
flatter.
different, right?
Yeah, it should be flatter, right? But here it is like a straight line. So
Okay, these type of questions always have a vague element to it. That's why you're never asked such questions. So technically, if you this one looks like, because multiplicity 3 looks like this. If you have multiplicity 3, it looks like this. But in the graph, it says it's this, right?
yes, ma'am.
So it has to be multiplicity 1, because only multiplicity 1 crosses so smoothly. Multiplicity 3, 5, and 7, all of these don't cross like this. They show a visible deviation from here. They look like this. But that's not given there. So ideally, we should consider it to be one multiplicity for each. But that's why I say they have a vague element to it. That's not important. If you have something like, but if you add something like this and this on the same side, even if they look very similar to each other, you can't say that the multiplicity of both of them has to be same, because it's quite possible that the multiplicity here is 3, but here it's 5.
Yes, ma'am.
Although that's not the case in the question that we're talking about, and
Yes.
that not something that you will be asked. So
Okay,
don't
ma'am.
worry. Okay. Then we
मैम मैं
have one more question. Yeah,
हाँ जी मैम क्वेश्चन ड्रॉप किया वही पूछना था
there are a lot of pictures. Let's go one by one.
मैम
What is the degree of polynomial? Calculate the number of turning points Px can have. Okay. It's better if you dictate this question, because every time I start writing, I have to close the chat box. Okay. We are discussing this one. So whoever had a doubt in this one, -x to the x plus 4 to the power something and a polynomial, can you dictate this polynomial? -x plus 4 to the power 8, x minus 4 to the power 3.
X minus 4 to the power 3 and x plus 12 power 5.
This is it, right? And you have to calculate the number of turning points. So this is the roots here are -4, 4, and -12. So it's this -12 here, -4 here, 0, and then 4. Looking at the n term behavior, this is for minus infinity, this is positive, this is negative, and this is also negative, and this is also negative. So overall, it's negative, right?
Yes, ma'am.
So this goes to this side. And then for the positive one, it's plus everywhere and negative here. So it's this. And then the degree is 8, 3, 11, and 5, 16. 16 is the degree. And the multiplicity of -4 is 8. The multiplicity of 4 is 3. And multiplicity of this is 5.
I might have 3 turning points, I think.
Okay, let's see. At -12, -4. So this will turn here. We know it has to turn at least once here. And then at -4, multiplicity is even, so it will be like this. And then at 4, we have odd multiplicity, so we at least have 1, 2, 3 turning points, right? This is the least number of turning points that this graph can have. But that's not the correct answer. Yeah.
Ma'am, you have said, ma'am, please you are the CI.
What?
मैं कर रहा हूँ, आप मैम CI नीचे करिए एक बार प्लीज. नहीं अरे मतलब ऊपर करिए मैम, मैं क्या कर रहा हूँ. हाँ मैम, आपने कहा कि odd at -4 it is odd multiplicity, okay? तो मैम ये
No, at -4 it's even.
-4 is
even है यहाँ पे.
हाँ, अगर वो odd होता तब क्या होता?
अगर वो odd होता तो वो इधर जाता यहाँ पे.
क्या मैम, अगर वो इवन है तो मतलब odd even मतलब ये डिसाइड करती क्या वो पॉजिटिव में जाएगा कि नेगेटिव में जाएगा?
No, odd and even decides if this is a root. Let's say if a is a root and x minus, you have a factor x minus a cube, then if we have odd degree here, that means it is going to cross the axis. So the x-axis is, this x-axis will be crossed by your graph. And if you have an even degree here, 2, 4 or something, that means it will go like this. That means it's not going to cross your axis. It will just touch your axis and go back to where it came from, there and then there. Is that okay?
Yes, ma'am. Okay.
Okay. So now let's see the number of turning points it can have. So the degree is 16. Maximum number of turning points it can have is
15.
Right. Now let's come to this one. We'll have to make use of the derivative, which is p dash x. If you will find p dash x, you will have, I'm taking minus sign common from here. So I'll have 8 x plus 4 to the power 7. Then x minus 4 cube and x plus 12 to the power 5 as it is. Then x plus 4 to the power 8. 3 x minus 4 squared and x plus 12 to the power 5. Then 5x plus 12 to the power 4, x plus 4 to the power 8, and x minus 4 to the power 3, right? So if you solve this thing, you will get minus, take x plus 4 to the power 7 common, x minus 4 to the power 2 common, and x plus 12 to the power 4 common. So you will be left with 8. This is x minus 4 and x plus 12. Then here you will have 3x plus 4, x minus 4. No, not x to the, not this one. This factor will be left, x plus 12. And then 5. This is taken common. This is there. And x minus 4 is also there, right? So the roots from here will be 4. So these are your turning points. The possible turning points are, we've already discussed this in summary. that your possible turning points are the points where your derivative becomes 0. The possible turning points are
I think
4,
-4, 4, 12,
4 minus 4,
12,
minus 12,
-12, yes, yes. And
and some roots from here, right?
yes, ma'am.
So this is a quadratic equation, right?
Yes,
So
yes.
you'll have 2 roots from here. Can someone find the roots of this equation? Anyone done with the roots of this one? The one that is in bracket.
Ma'am, we have to find the roots of this equation.
Yeah,
Okay.
find the root of this equation, the one that's in bracket. Solve it.
Okay.
It's a quadratic equation. Find the roots.
ओके मैम, मतलब कि मैम जब इन सबको मल्टीप्लाई करें तो मुझे क्वाड्रेटिक इक्वेशन मिलेगा,
Yeah.
उसका मुझे रूट फाइंड करना है।
हाँ जी, उसका रूट फाइंड करना है। 2 रूट्स आएंगे। Then someone quickly tell me कौन से रूट्स है?
मैम ये तो क्वाड्रेटिक इक्वेशन तो बहुत बड़ा हो जाएगा, तो इसको तो सॉल्व करना पड़ेगा फिर अच्छे से।
मैम 5 वाले का ±4 आ रहा है, 5 मल्टीपल +-4
This entire thing.
और
Find the roots of this entire equation.
I think
This one.
4, 12.
Just put it somewhere.
Means ma'am, I have to put turning points.
Or you'll have to simplify this entire thing and find the roots. It will be a quadratic equation, and you just have to use the quadratic formula. That's it. But it's going to take time. That's why I'm. Can someone just put this equation in some solving tool online and find the solution?
Trying, ma'am.
Found? What are the roots?
Uh,
Yes, ma'am.
it is minus
There are
12
two roots.
4 minus 4 by 3 and 4.
Minus 4 by 3 and
4.
4. So 4 is here only. You don't have to write it again. So the roots of this equation are minus 4 by 3 and 4. Is it? Roots of this one, the one that's in bracket.
Yes, ma'am. X comes to be -4. Rest I'm checking it.
Okay.
Can you please tell that how we can find that root by without simplifying this?
What?
Ma'am,
Speak a little louder.
Ma'am,
Yeah.
without simplifying it, how I can find the root of this?
You can't find the roots of this without simplifying it. You'll have to simplify. No one yet has found the roots to this equation. Or should we solve it
Yes,
here
ma'am. I
only?
have found there are two
What are the
roots.
roots?
One is 9.17 something and minus 2.17 something.
No, not in points. Just tell me in fractions.
Ma'am, I have put the graph in Desmos app, so it is giving me in points.
Okay, it's this -7 plus square root of 129 by 2 and -7 minus square root of 129 by 2. These are the roots of this quadratic equation, this one. So now your possible turning points are the roots of P dash X, and your roots of P dash X are these. And out of this, I already know that 4 is not a turning point. You see, 4 is not a turning point, neither is 12, minus 12. So 4 and 12, minus 12 are not turning points. So the only possible turning points are these. This one, and this one. Now minus 7 is somewhat here. Between minus 12 and minus 4, right? And then they're saying that there are roots here, there are turning points here, right? It's minus 7 plus something and minus 7 by 2 plus something and minus 7 by 2 minus something. Minus 7 by 2 is minus 3.5.
Ma'am, it having a root minus 7 only.
This has root minus 7.
Yes, minus 7 and minus 4 at 7.
I don't think so. I've checked it on 8x minus 4 plus 12. 4. Minus 7 is not a root here. I don't think so. If you put minus 7,
नो मैम,
please check carefully.
मैम आपने जो आपने रूट लिखा है, जो रूट लिखे हैं वो दोनों सही है, वही रूट है, सिंपलीफाई करने पे वही आ रहे हैं. हाँ जी मैम.
Okay. So those are the roots. So this is minus 3.5 plus something and minus 3 plus something, right? So
Yes,
your
ma'am.
roots are here. 3.5 is somewhat here. So one of your turning points is here and one of your turning points is here. So you have two turning points here. So let's see if we'll draw those two turning points, what will happen. It will be this thing, then this thing, right? But let's say if you have only two turning points, now what's happening is you have a turning point. Let's say I have a turning point here and I have a turning point here. This is minus 3.5 minus something. This is minus 3.5 plus something, right? These two things are these. Now, if I have turning points here, then I should go from here. This is a turning point. Then again, we have a turning point here, let's say. If that's the case, then shouldn't I be coming back here, right? That means I'll need one more turning point. And if this were a turning point, if you have two turning points here and here, you will first go up because this is a turning point. For you to have a turning point here, you'll have to go up and then come back down again. Then if this is also a turning point, then you'll have to go down and then come back up again. So eventually your graph will be led here, right? But I want my graph to turn down because it has to meet here, right? So I'll need one more root of P dash X after minus 3.5 plus something. This is minus 3.5 plus this is this root. Where is it? This one. Minus 3.5 plus something, right? This is that root of your P dash X. If you have to, you will have to turn down. There is no other way, right? That means you'll have to have a turning point after minus 3.5 plus something and before 4. You will have to have a turning point between minus 3.5 plus whatever this thing is and 4. There should be a turning point between these two numbers. But if there were a turning point between these two numbers, you will see it here because these are the only turning points, right? Is that clear?
Yes, ma'am.
That means there are no these two are not turning points. That means you should go like this. Is that okay?
Because their points not again not cut the point. That's why that are not turning point, ना मैम.
What can you repeat again?
मैम वहाँ पे वो दो पॉइंट हमने जहाँ पे minus 3.5 प्लस लिखा है वो दोनों पॉइंट पे जब लाइन कट नहीं करी इसलिए वो टर्निंग पॉइंट्स नहीं है ना मैम.
No. हो क्या रहा है यहाँ पे आपके पास पे दो पॉइंट्स है. So the possibilities of turning points are these, right? So you only have two turning points left other than these three. One is minus 3.5 plus something और दूसरा वाला minus 3.5 plus minus something, right? So if this is, let's say this is minus 3.5, then minus 3.5 plus minus something is this point, minus 3.5 plus something is this point, right? These two are your turning points. Now, if these are your turning points, इधर से ग्राफ पहले ऊपर जाएगा फिर नीचे आएगा because it's a turning point. Then इस वाले के लिए ये नीचे जाएगा फिर ऊपर जाएगा because this is a turning point. अब आपका ग्राफ ऊपर ही रह जाएगा ना, बट यहाँ पे रूट के लिए नीचे आना पड़ेगा, राइट?
यस मैम।
तो ये बन नहीं पाएगा क्योंकि आपके पास में और पॉसिबिलिटी नहीं है इधर। माइनस 3.5 के बाद कोई रूट नहीं है इसका यहाँ पे, इसलिए द ओनली पॉसिबिलिटी इज दिस।
ओके मैम।
Cut set 4. So your turning points are 1, 2, 3. Is that okay?
Ma'am, one last thing. Ma'am, I just want to know what's the process of solving this question. So the question is, there are 3 airports and 2 people are trying to, one person goes from A to C and the other person is going from B to C. So the distance from A to C is 1200 kilometer, 1200 kilometer, and it's slowed down, and so its average speed got reduced by 200 kilometer per hour, and therefore the time increased by 30 minutes. Now the second person who's going from B to C, the distance between the 2 points is 1800 kilometer, and this flight has an average speed of 720 kilometer per hour. So now they're asking who is going to reach first and how much time will they have to wait.
And is this 200 kilometer per hour, is this the average speed or is this the amount by which your speed is reduced?
It was reduced by 200 kilometer per hour.
And we don't have the average speed for this one?
The first, from point A to C, they haven't given the initial speed.
Okay. What's the question then? What do we have to find?
Who is going to reach first and how much time will they have to wait for the next person to come? Ma'am, the second one is 720 kilometer per hour, the average speed.
Okay, this is 1200 kilometers. Then speed is given to be reduced by
200
wait,
kilometers.
why is this? Can you repeat the route from A to C? Why did this get reduced?
Due to bad weather, the flight slowed down. So the average speed was reduced by 200 kilometer per hour.
Okay, so
and
initially it was X kilometer per hour, let's say, and then it got reduced by 200 kilometer per hour. Okay.
And time increased by 30 minutes.
Okay. D1 plus D2, two distances, they're equal to 1200. Then for D1 distance, it was X kilometer per hour, D1 by
time.
the time increased by 30 minutes, right?
Yes, ma'am.
30 minutes as okay, so the usual time was supposed to be something else and the flight was delayed by 30 minutes. That's the question, right?
Yes, ma'am.
Okay. So 1200 here, and by usual speed, let's call that speed X. And time was, let's say, T. This is it. And then they say that if X gets decreased by 200, then your time gets increased by 30 minutes, right? But this is in per hour, right? So we should take this in hour. This should be
0.5.
half hour, right? 0.5 hour. So your time should be then T plus 0.5. This is 1. Then, okay. This is 2. And then this is 1800 kilometers. And the average speed for this was
720. That is there.
720. And the time we don't know, right? T1, T1. And let's take the time T2 here.
Yes.
So now we have 3 variables and 3 equations, right?
Yes.
But this variable
Yeah.
is not involved anywhere else.
Yes, ma'am. I think this one we directly got the person B's
Yeah, yeah.
time.
T2 is 1800 by 720. So you get T2 directly from here. And then you have 2 equations in 2 variables, right?
Yes.
So you just have to
And
solve these. Yeah.
then T1 plus 0.5 is going to be the person's time. Okay.
Yeah. T1 plus 0.5 would be the time, and then you have to find the difference, right? Who reached first,
Yes.
and
How much different?
yeah,
Yes.
that's how you have
Thank
to do it. Just subtract these two. Okay. So do we have anything else? Can we end this session?
Yes, ma'am. Could you please tell us how to answer the questions which ask for the value of a constant C for minimizing the sum squared error?
Okay. So let's say can you give me a question? Let's say you
Yes,
have,
ma'am.
yeah.
Any simple example is fine. Like the process
Okay,
and
I
step.
thought you were coming up with some example. Now I'll have to look for one. 1 second. Just 1 second. Okay, I could not find one in activity questions. So your what exactly is your question?
How
That way
to
I can frame one
answer
question.
the
If
value.
Yeah. Value of constant, but that's why I need the question, right?
Ma'am, I have a question of this type.
Yeah, go ahead.
The function is f of x equal to minus of x minus 1 the whole square into x minus 3 into x minus 5 into x minus 7 plus c. And we need to find the value of c so that sum squared error is minimum.
Okay.
And variable
Okay.
is x, y, when x is 1, y is 4, x is 2, y is 18, x
Just
is
1
3.
second. 4. Y is what?
When
Just
x when
1,
x is
2. Yeah.
x is 1, y is 4, x is 2, y is 18, x is 3, y is 4, x is 4, y is minus 24, x is 5, and y is 3.
Okay. So you have to find the value of C. But why do you need the data for this? If you have to find the value of C such that this thing is minimized, the first thing is you have to find the derivative, right? And then you have to equate the derivative to 0. Okay. Okay. Got the question now. So you have to put x equals to 1 here. Just put x equals to 1. What will be the actual value at x equals to 1? This is
Minus 1 the
1.
whole square. X minus 1. So it will be 0. It's x minus 1 the whole square. F of x equal to minus of x minus 1 the whole square.
What's the value of this entire expression at 1, at x equals to 1?
The expression is x minus 1. the whole square. Ma'am, you have written as
This
x plus,
this one?
yeah, it's x minus 1. So it'll be 0 when x is 1.
Okay, okay. So this is 0. Then at 2, this will be 1. This will be minus 1. This will be minus 3. And this will be 9. So this is 27 and negative 27, right? Plus constant. And this is also plus constant. 0 plus constant. And this is 27 negative, right? Minus 27 plus constant. Then at 3, this will be, you just have to, let's say, because I don't want to waste time here. Let's say this is C plus 30, or let's say
Ma'am, it'll
10.
be 0.
Ma'am, it is 0. 0.
Okay, this one 0
X
to,
minus 3. X minus 3.
okay, this is 0. Then at 4, this is 1, this is also 1. No, this is 3, right? This is 3, this is 1, then this is minus 1, and this is 4 plus 7, 11. So this will be 33.
It will be
plus
99.
constant and
Ma'am, it will be 99. V square. X minus 1 whole
okay,
square.
okay. This is 99 plus constant, and then at 5, it's 0,
0
right?
plus C.
0 plus constant. Now, what you have to do is take this one, subtract y from this, and take the square of it, right? So this will be C minus 4 whole square plus minus 27. Okay, minus 20. Is it minus 27 or plus 27? Plus 27 would have been easier. If you have 2 here, this is 1. This is minus 1. This is minus 3. And this is 9. Right? 9,
Ma'am,
3,
it will be
27.
minus only.
Okay. Then it'll be 45, right? C plus 45 whole square. If you will take this one, this will be C minus 4 square again. If you will take this one, this is 99, right? 99 plus 24. How much is it? It's 123, right? 123 plus, are you sure this is the right question? Because your solutions are not supposed to be this lengthy. C minus 3 whole square. Now what you have to do is just open these squares. Eventually you will get a quadratic equation, right? By solving this, you will get a quadratic equation. Let's call it ax square plus bx plus c equals to, this is the
90.
quadratic equation that you get. What?
Ma'am, I don't think it's 99 when you put 4 in the equation. It'll be
4
9 into
from here. Yeah,
there.
what's it?
9, then minus 1. Ma'am, it's x minus 7. I think when you have written x plus 7. That's why it went mistake.
Okay. Then everything's going to change. I think this too shall change. So only these 0 ones are going to remain same. These two are going to change. So if I'll put 2 here, this will be 1. This will be minus 1. This will be minus 3. And this will be 2 minus 7 minus 5, right? So this will be
Minus
15 plus C.
negative 4 times
15 plus
15. Okay. And similarly at 3, you will have 2. Okay, 3 is 0, right? At 4, you will have 3. This is 1. This is 4 minus 1.
Minus 27.
This is minus 3. This is 9 and
Yeah, minus
9
27.
minus
Minus
27.
27.
Okay. Now things will become nice. Expression will not be this lengthy. So this should be 15 minus 18 or 18 minus 15. Okay, let's do 15 minus 18. This will be C minus 3 whole square Then this one is the usual. It remains same. And then this is C, and this expression will be
C minus 3.
plus 24. So this will be
C
minus
plus
3.
3.
C minus 3, right?
Yeah.
Yes, ma'am.
And this is
Hmm.
also C minus 3 square. So we have C minus 3 square a lot of times. This is 3 times C minus 3 whole square and 2 times C minus 4 squared. You have to minimize this expression. So to minimize this, you don't even have to simplify it. I'll suggest you that you directly take the derivative of this. So if this is sum of square errors, your sum of square errors derivative is 6 times C minus 3 plus 4 times C minus 4, right? And equate this to 0. So what will be the value of C? This is 6C minus 18 plus 4C minus 20, 16. So this will be 10C. And on the other side, we'll have 20, 34. So C will be 3.4. Is this okay?
Ma'am, another way we could do is SSC, the most minimum value it could get is 0, right? So we equate the SSC equal to 0 and simplify, then we can get the same answer, right?
Yeah, you can do that too. That's fine. Okay.
Thank you, ma'am.
So you had to find what was asked, the value of C or the minimum, this.
Value of C value.
Okay. So we're done, right? Anything else? Do you guys have any other doubts?
No, ma'am. Just wish us luck for qualifiers.
Yeah. All the best for your qualifiers.
Thank you so much.
And okay.
Ma'am, can you tell how many questions will come in the qualifier exam in math?
The total
Mm.
number of questions would be just 1 second. So it's like around 11 questions, 11, 12. There's subparts too. So including the subparts and all, you will like 15 something questions.
In 4 hour, ma'am, it have a dividing a time for each subject, or we can choose any one subject according to our.
I don't know about that. I think you will only be given 1 hour for each subject. But I'm not sure about it.
No, in English, I have seen that it having a 40 to 50 question.
Okay.
Then 1 hour. I am confusing in this only.
That's based on maybe the English questions require less time to solve. That's why there are more questions there. In maths, you're going to, each question needs time to get solved, right? That's why you have less number of questions.
In statics, math and CT, it having a minimum 11 to 15 questions, and only English having a 40 to 50 questions.
Okay. So anything else? Any other doubts from what we've discussed, from what is not discussed?
Now the
Okay. So I'll stop sharing the screen and we'll end this session here then. Okay. All the best for your qualifier and quiz 1.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you, ma'am.